here we have, I just started with the pandas and I had given just an intro to pandas, right? And I told you what, just a minute, here we had seen how can we fetch, how can we add a new column, how can we rename a column, and thereafter we take a data. In that data we just picked up, or we just try to understand how to find missing values, and thereafter dropping a column, fair enough, and thereafter identifying outliers and working around it, and some visualizations also we did.
Bipul, I had one question, not on the code, but on the box plot, right? Box and whiskers plot that you did for outliers analysis. Can you help me? I always get. Can you help me understand this box plot a little bit? That would be very helpful. I know that the box is the IQR, but I'm a little confused around the values at the.
Understand, sir. I'll explain.
Yeah, if you could, that's the only
today it will be it will get clear for you.
Okay.
Yeah. So for working with this thing, okay, let's take a case study. And okay, so what I'm planning to have a case study today, and around that case study our complete discussion will be there, right? So just a minute. I'll share the data set with you. Which case study shall I take? BigMart is fine. Okay, fine. Let's go to the BigMart. It is not that complicated and not so simple as well. It is something in intermediate. It is downloaded. I'm sharing the link with you meanwhile, and later on also I'll update this link in your this one, that is your Git.
Sure.
Okay, so let's see. Okay, so let's see over here. I will take this thing. Import pandas as PD. Import numpy as NP. Import Matplotlib we have not used yet.
Yes.
We are going to start with the Matplotlib as well with this case study, right?
Yes, sir. And sir, that the JSON one also you will help us to understand, right?
Right. JSON file you want to read, right?
Yes. How we can do simple analysis. Because if it can become CSV, then it's very easy to do it, because the Matplotlib and all are just libraries. You can probably plot anything, do anything. But JSON file, I don't know how to read it properly, how to analyze that, because it's like in a dictionary structure.
Correct. Okay, so now over here I'll read this data file. So pd.read underscore CSV. I will directly read it from the Git. So I'll pass this location over here and df.head. So now it is not accessing. The reason is here the data is Excel, right? It is not a CSV data. It is Excel data. So how can we read the Excel data over here? Okay. So to read the Excel data, can we use separator is equals to vertical line? No, it's not working, right? So what can we do? Sometimes this also works, okay, in simple Excel. Otherwise, you can also use read Excel directly. So you have a data over here. So now let's see, first try to understand data. First column is just a useless column. So I can make this column as an index column. Okay. So now that column becomes index column. Now we have an item identifier representing all the items coded version, like FD is for food, DR is for drink, NC is for non-consumable. Then weight of the item. Then we have item fat content, that how much fat any item is containing. What is the visibility that's been monitored using some of the tool that these supermarket may have. Thereafter, we have item type, dairy, soft drink, something. Then MRP of the item, right? So up to here, it is all about the property of certain items. Okay. Thereafter, we have an outlet identifier. Okay. Then after we have outlet establishment here when it was established. Then we have outlet size. It's a small, medium, or high. Then outlet location type like tier 1, tier 2, or tier 3. Then you have outlet type. It's supermarket 1, 2, or 3. Then item outlet sales like this. And then we have a quantity sold. Fair enough. So we will take this case study end to end. Okay. First, we'll try to understand if we have these kind of data, then what are the possible irregularities in this data. Once we understand the possible irregularities, thereafter we'll fix those. It can be missing value, it can be outliers, it can be anything. And thereafter, I will start with the machine learning concepts and try to explain how can we build a machine learning model to predict certain entity like outlet sales. And after building up the machine learning model, we will also see like what kind of tuning we can do so that the predictions accuracy can be improved and error can be decreased, right? So these all things we are going to do over here. So how do I start? Like if I get the data first, what is the first thing? Whenever you have a data, the very first thing you need to check is quality of data. Okay, data quality assurance is very important. Okay, so the quality of data you can check. The very first thing is data quality. Okay, so how do we ensure the data quality? We ensure the data quality by checking all the data types. Okay, that means we will check that in a single column. Okay, is it like that there are multiple types of data existing? Okay, like obviously single column is homogeneous over here. Okay, pandas are having a homogeneous nature of any data series or any data column, but there is a possibility that like suppose it is mentioned over here price, somewhere the price is mentioned, let's say like this. Okay, somewhere it is mentioned like this, rupees 7, right? Now as rupees symbol is there, right, now it can't remain numerical. Okay, it will become a non-numerical entity. So because of any single non-numerical entity, all of them will become non-numerical, right? So what we don't want such kind of situation over here. So that's what we'll try to check the data types. Okay, second we will check over here if there is any missing values, right? Third, we will check if there is any possible outliers. Okay, fourth, we will check is there any possibility of multicollinearity. Okay, now what is multicollinearity? I have not explained yet. I know I'll explain it in detail, right? And then yeah, this is enough, right? And we'll also check the skewness.
Yeah, skewness.
Yes.
Skewness of the data, right? So
Correct,
these
correct.
like data like when you go for any data science kind of interview, so generally this is one of the very often question that they ask, like how do you ensure the data quality, right? So by if you mention 3-4 points, that means they know that you are aware with the what are the irregularities possible in the data, right? So first we start with identifying the data types. So how do we identify data types? To identify data types, it's very simple. You will just run over df.dtypes. Or before that, let's check the shape so that we can have a general idea that what size of data we are working. Okay, it is close to 8,523. All right. Now we'll do what? df.dtypes. You can use dtypes, right? So you'll get the information that what are the types of each column, right? So sometimes when you have a very large number of columns, identifying them or reading them one by one is little difficult. Okay, that means keeping in mind like, okay, this is object, this is float or something. So what we do, we have one more way, that is called select d types. Okay, so if I will use select d types, I can select only the numerical and non-numerical separately. All right, so here All right.
So the non-numerical goes left and the no, and
No,
the
no, it is just
numerical goes
filtered. Here we have only the numerical data separated. Okay. And then
okay.
we will separate,
Number.
right?
Okay.
And then if
Okay.
I
Number
write over
means
here exclude, instead of include, I'll write over just exclude. Okay. So only non-numerical data will be picked up. So in the non-numerical, it can be a string character, it can be a date type as well, right? So now we have this one.
yes. This is better. Yeah.
And that my what are the columns in my data are numerical and what are non-numerical. Okay, so that we can plan our whole process accordingly, right? So first we have item where it is numerical, looking numerical, this is numerical, this is numerical. Now this is numerical, right? So whenever we have these kind of information, year, so year used to be in larger in magnitude, like 1991, 1999, 2009 or something. So analyzing, if you want to just analyze like in which year how much sales were there, okay, or how many quantity we sold, right, or what are the different factors, year wise analysis you want to do, then you can use this column, right? But later on, if you want to use it for machine learning model, okay, so it is recommended that instead of year, use the age, right? If you have a year information, just convert into age. How can you convert into age? Very simple. Take the current year, right, and subtract it, right? So why it is good? If I will use year, is there any problem? No, there is no problem. The reason is if you use a age, the magnitude of these values will be reduced, right? Like it is 1999, it will become something 26, right? This will become 26. So magnitude will reduce, but you will not lose any information, isn't it? So it's like, when later on any processing will happen for the machine learning process, okay, any calculations will happen, that processing or calculation will be done faster, because it's very simple. If I ask you, do 26 multiplied by 2, you'll take lesser time, right? You can say that, okay, 26 multiplied by 2 is 44 something, right? And but 44, right? Whatever, 52, like, yeah, 52. You can say like, okay, 26 multiplied by 2, 52. But if I'll ask you, do one thing, 1999 multiplied by 2, so you may take little bit more time. And second thing, 26 is something which can be stored in 8-bit. This is 8-bit data, right? Because 0 to 255 is what, 8-bit data, isn't it? But this is not a 8-bit data, this is 16-bit data, right? So it's like, this will take lesser space to store, this can be processed faster, okay, but this will take more space to store, and it will take little bit more time to process. So if we have a smaller data, then these things don't affect much. But as a data scientist, we need to think of very large scale data. So in that case, these small difference can affect a lot, the processing time, the resource consumption, and everything, right? So that's why these kind of process we'll use later. Then we have outlet sales, then we have a quantity sold. Okay, then we come to this part, this one, that is non-numerical. So in the non-numerical, this is looking non-numerical, that is fine. Okay, thereafter we have this also non-numerical, that is fine. Item type is non-numerical. Okay, this guy, as per the initial 5 samples, I can consider that first 4 characters are exactly same. This is not creating any difference. Okay, it may not be true for other samples, may we have some differences, but initially this thing comes into my mind that, okay, these 4 characters, if suppose this is same for all the samples, then we don't need it, because this is not creating any difference. We only need these values, which is creating difference between the sample size, between the samples. So that process also will try to do. Outlet size is fine, location type is fine, and this one is also fine. So here also I can remove the tier, so that I will have only 1, 2, 3. Okay, so this will give us a generic idea that what we can do later, right? Next, once we data type, then we'll try to check, do we have any missing values? So that we'll check over df dot is na dot sum. is NA. If I'll run, I'll get like in which column we have a missing value. Wherever it is missing value, that will represent true. Okay, this is true. Okay, this is true means what? It is missing value. So now if I run some function, I will get the exact idea that where are missing value existing. Okay, so here we have a missing values and here we have a missing values. Fair enough? Okay. So one column is numerical where missing values are there, other column is non-numerical. So it is very good thing that we will handle both the type of missing value in this problem statement, numerical as well as non-numerical. Okay, and one more thing, it is like here will the approach for numerical will be different and the approach for non-numerical will be totally different. We have not fixed the missing values in non-numerical. And second, we can't remove the column or rows over here. Why can't we remove the column or rows? Because the size of missing value is not lesser than 1%. Okay, it is 28% and 17%. And it is not more than 50% as well. If it is more than 50%, we can drop the column. Okay, if it is lesser than what? 1%, we can drop the rows. That means we have to impute something over here. Okay, so imputation will be done. Next, we will check, is there any outliers we have? Let's check the outliers. df dot what? Summary, or sorry, describe.
So the second column has more than 1% of missing values, 1.7.
No, this is
the second one also 2.8.
No, this is not 1.7. This is 17 actually.
Yeah.
This is 17. Okay.
So because if you multiplied it by 100, right?
17% and 28%.
Right. 17%, 28%, right?
Okay. So then in that case, we will not be removing the rows.
Right. Because if you remove the rows, you will lose 17% of the data.
Okay, got it.
Okay, that's a large number, right? You can't afford losing, because in any case, right, we don't afford losing more than 1% of the data, right? If there is very kind of exceptional case also, then also we remove up to 2%. Okay, right? But like suppose you are working with some healthcare data in which you have some records like heartbeat or kind of blood pressure. So those are very critical values, right? So in that case, we consider removing the rows. Right? Even if it is 20%, then also we consider removing the rows, because those are very health critical data. And you can't, if blood pressure is not known or if heart rate is not known, you can't impute anything over there, right? You can't calculate like, okay, statistically, let's calculate average heart rate, calculate the average blood pressure. That should we not use in healthcare aspects.
Okay.
Isn't it?
Here, if it is just the 1% or 2%, then we can delete the rows.
Right.
Otherwise, if it's 17%, 28%, then we will not, because obviously then it will we are deleting too many rows. But for columns, the percentage should be how much if you want to review the column?
For the columns, it should be at least more than 50%.
Okay, fine.
Yeah, like for example, last case, Kbin was having 687 missing value. That was close to 80%, 77%. So if suppose more than majority of the data is missing in any column, that means that column becomes a useless column. Right? So because to calculate, to statistically calculate like what can we use here, we need at least more than 50% sample.
That's right.
Right?
Correct. Similar is the case with multicollinearity, that too many columns are this thing. So we delete the thing which is not affecting the analysis or the output of the thing, which is just
right. But multicollinearity is something I'll explain multicollinearity. Don't worry. Okay.
So people, one quick question. So you're saying that if there are missing values, the percentage is more than 1%, then we cannot take those 50%, right? Then we cannot take them. Then we cannot take them out, right? No,
correct.
We cannot take them out. Okay.
Yeah, unless it is very critical data like healthcare data.
Correct. So then we'll have to kind of think about imputing them.
imputing them, right?
Okay, got it.
Right. So we have to just think of like here, even if suppose item weight is there, right? So whatever the item weight that I know, like I know almost 83% of the item weight, right? So using 83% of the item weight, we'll try to find out best possible value like mean or median, okay, to impute these blank spaces, right? Okay. Next. Okay, but imputation is having so many, kind of rules are there, right? I'll explain them. Like it depends upon what are the column. Like for example, you are working with the temperature data, right? Again, now if you're working with the temperature data, right, and you have a temperature values like this, let's say it is 18, it is 17, okay, it is suppose 19, it is suppose again 18.5. Here we have a missing values. It is suppose 21. It is suppose 25, 30, right, 32 and 35, right? Now if you take the average of it, okay, what would be the average? Let's take the average. I'll calculate the average over here. 18 plus 17 plus 19 plus 18.5 plus 21 plus 25 plus 30 plus 32 plus 35. Okay, how many? 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 9, 9, right? So it is 23, right? So can I use 23 over here? See, the point over here is I can use 23, okay, like this, okay. But again, in such case, suppose here average is 23. Suppose here average I am getting 25. Okay. So all of a sudden from 18 to 25, okay, it is little, and again coming back to 21. Okay, it is little something, it may not be close to reality, right? So in such kind of case, in which we know that values will change gradually. Okay, it will, like here weight will not change gradually. Weight can be anything up and down, but here we know that values will change gradually for each day, right? So from 18.5 it may goes to 19 or it may goes to 17, but it will not change too much. Okay, it will not change too much, isn't it? So that's why what we do, we will use over here some values like same values I can repeat over here like 18.5, okay, this value, or we can take the average of these two entity, 18.5 and 21, okay, the average of these two guys, right? So that approach also we take for treating the missing values. Okay, so missing value treatment involves a lot of different strategy, right, depending upon how your data is existing, right? So when I take some other kind of case study, I'll also tell you what are the different, like how missing values are treated in different kinds of situations, that you can only understand if I will just tell you everything over here. Then later on you may forget. But when I take similar kind of case study, like okay, first we will use mean median. Here we can't use mean median because it is not a numerical. So what we will do here, that we are going to explore. When I take this kind of data, then also I'll explain, right? When I use a data something different, like for example, I am working with the property data. Okay, so in the property data, suppose I have a property from 3 different area, right? Area 1, okay, area 2, like let's say this is Whitefield, okay, Whitefield in Bangalore, right? This is very expensive, right? This is let's say Indiranagar, okay, right? And area 2, and this is any other location anyone knows in Bangalore?
Jayanagar.
Some cheaper location, some affordable. Jayanagar is affordable.
I think so, probably. I don't live.
I don't live in Bangalore.
Okay,
maybe Whitefield, Indiranagar, Brigade Road, all these places, but these are well-established ones actually.
Right. So
Yeah,
let's say
Nandi Hills is actually coming up. It's very good, but it's still inexpensive to buy property there.
Okay, fine. So let's say we have a Nandi Hills over here, right? Right, and I have a property data, right? And here I have a price of the properties, right? some like say here I have 40,000 rupees a square feet, okay, 35,000, okay, 50,000, like this. Okay, here I have, let's say, something 25,000, okay, 30,000, okay, 35,000. Okay, here let's say I have 10,000. 10,000 may not be there, but it's still 12,000. Okay, and then 14,000. Right now, suppose some values are missing. Okay, some values are missing over here. For Jayanagar, some values are missing. Now, if I take the overall average, okay, so that average value may be higher for this particular area, right? Because these values are quite high. This is comparatively lower. So overall average, if I took, right? So in that case, the value that I calculate for Nandi Hills, where the value is unknown or it is missing, may be higher compared to these guys. That means I may create a outlier for Nandi Hills, right? So in that case, what we do, we calculate the average, or we calculate any statistical value for each category separately, right? If it is missing in Indiranagar, so we just consider the data of Indiranagar to fix this particular missing value. Okay, if there is missing value over here in the white field, so we just consider this guy, because all of them are having different price ranges. So that's also we do, that is called categorical analysis for each of the data, right? So that kind of approach we will also take. So there are multiple ways of handling the missing values, and that we can understand once we will have such kind of data, right? So let's have a understanding of it. Just allow me for a minute. Okay, so let's proceed. Fine. So here what we do, we have missing values and all. Now I was telling you about, so missing values treatment we'll discuss. Thereafter we are thinking of outliers. So let's try to analyze. Outliers will be there over here in the non-numerical columns. So here item weights, this is our mean and this is our median. Okay, and this is standard deviation, this is minimum value, this is maximum value, right? Now what is this value? That means 75% of the sample are having a weight lesser than 16, and 25% of the sample are having a weight lesser than 8.77. But these two entity helps us to understand the possibility of outlier. So as mean and median is very close, okay, the possibility of outlier is very less. Okay, because I told you that let's say I have a data samples over here, okay, and I calculate the mean of it. What is mean? 2.83. What is median? 2.5. Okay, average of 2 and 3. Now I have a data sample over here. Okay, one outlier I use, extreme high value, right? Extreme high value compared to majority. Like this is a portion in which your most of the data exists. Now if I calculate mean, it will be 11. What is median? Median will be 3. Okay, so you can say median don't generally get affected by the outliers, because median will be calculated positionally. Okay, we just use the position of the data, the sorted data. First we sort the data and the middle value. But mean do get affected. Mean do get affected. Mean you can see affected, right? So if mean and median are close, the chances of outliers are very less. Okay, in item visibility, we can say that here also there is a lesser chance of outliers, but we will explore it better by visualization and all. Here 140 and it is 140. It is very less. The chances is very less, right? Established, this is just a year anyway. Sales we have over here is 2181, and this is this one. So here we can see a good sort of difference. So we'll check it out. And here also the chances of outliers are lesser. So with the describe, we get a general idea that, okay, how outliers are, like which column may have outlier, which column may not have outlier. But we will confirm it later on once we will have what? The complete visualization and everything. Okay, so that we'll explore. Next, I told you about, like, we'll explore the multicollinearity. Now, what is multicollinearity? Multicollinearity is like, let me explain. Suppose I have a feature 1, okay, then feature 2, then feature 3, then feature 4, and then we have a target column. So what we want? We want to use these features to build a system which can predict the target, right? That means after doing the descriptive analysis, right now we are doing the descriptive analysis. Descriptive analysis is what? Is just analyzing and describing your data. Then we do predictive analysis. Predictive analysis is what? Is like just try to make some prediction. This is a part of machine learning, right? Now, if I want to use these entity to predict sales, so what I want these to be, this should have a good sort of relationship with the target. Okay, these should have a good relationship with the target. Then only the prediction will be good, accuracy will be good, isn't it? But let's consider we have a feature over here, and that feature is having a value like 2, 7, 3, 4, 5. Okay, and here I have a feature. Let's say these are also some features. Okay, I have over here 3, 9, 4, 5, 6. Okay, now, and the target value is, let's say over here 10, 15. Okay, and then I have 12. Let's say 13, and then I have, let's say, again 15. Now, if you see these two things, which one? These two columns. Okay, I'll just put it over here, F1 and F2. Okay, 1, 2, 3, 4, 5, 6. Okay, 1, 2, 3, 4, 5, and then 6. Okay, now the first is 2 and 3. So let's say 2 and 3. Okay, thereafter we have 7 and 9. Okay, let's say 7, and here 7, 8, 9. Okay, so 7 and 9 goes over here, something over here, right? Thereafter we have 3 and 4. 3 and 4 is coming over here, right? 4 and 5. 4 and 5 is coming over here. Okay, 5 and 6 is coming over here. Okay, so now these are very highly correlated with each other. Okay, between them the correlation is very high. That means whenever F1 is increasing, whenever F2 is increasing, F3 is also increasing. Very huge correlation, right? So when you build up the model at the end, you can't do the prescriptive analysis. Prescriptive means what? Prescribing some of the important information out of your whole process. You can't give any suggestion that this target is actually affected by which feature more. Is it this guy is affecting it more, or is it this guy is affecting more? Isn't it? Because both are very highly correlated. So target is there. You can build up any model. You can easily make the target prediction. Everything can be done. But you can't kind of do any kind of prescription. You can't kind of explain. You can't explain your model that whether F2 is affecting the target more or F3 is affecting the target more. Okay. So that is a case of what? Multicollinearity. Okay, so that's also we need to identify and fix. All right, so don't worry, we'll go into the very much detail of it. As of now, I'm just giving you the initial understanding that what actually will happen. So to identify the multicollinearity, what we do, we check the correlation. Had I covered correlation in last class? No,
you haven't. But yeah, correlation is about understanding the relationship between two variables.
Correct. I have not covered it anyway. So now here I am trying to use the correlation. So it is saying that it can't be used because of non-numerical entity, right? So what I can do here, I can use dot select d types include
is with numbers, because correlation can only be found between numbers, not categorical.
Correct. So now if I check it over here, the correlation values will ranges from -1 to 1. Okay, so if it is close to 1, it will highly correlate. Like for example, over here, these two are having a very strong correlation, sales and sold. quantity sold. Obviously, if you sell more quantity, you will have more sales, right? If it is close to 0, that means it is very weak correlation, right? Like for example, this guy, okay, it is negative and it is also close to 0, right? That means it is having a negative. That means new, you can say new stores are having a comparatively lesser sales because negative. That means when the year is increasing, that means all the new stores are having comparatively lesser sales compared to old stores, okay? But it is very close to 0, it means this guy is not having very much a strong correlation with sales, okay? It is something intermediate, not very high, not very low, okay? This is what, again, negative, but it is not very close to 0, okay? This is close to 0. So this helps us in understanding how different columns are related to each other, okay? And this also helps us in identifying the multicollinearity, like is it there that few columns are having a very high correlation or not, right? So those things also we'll try to figure out, okay? So, and last I told you about the skewness, okay? Skewness is what? See, whenever I talk about the data distribution,
Normal distribution. It should follow the normal distribution.
right? So if I will just take over data distribution, okay, see, we have this kind of like different kinds of distributions we used to be there, right? Like for example, let's say this one. Oh, it's looking very small. Okay, so if you see, this is called different kinds of distribution. This is normal distribution, okay? So normal distribution is like number of samples before mean and after mean is almost same. This is a less biased data. The data is less biased because number of samples before and after mean is almost same, and mean and median is also very close to each other. This is a best scenario data. This is what uniform distribution, okay? This is a binomial distribution in which mostly we have true or false, yes or no, okay? Then we have a Poisson distribution, okay? Here now what is Poisson distribution? It is basically defined kind of in a range, okay? We'll explain this Poisson distribution as well in detail, okay? Once I'll explain binomial, then you can understand Poisson better. Then next we have exponential. This used to be something, these two things used to be what? Right skewed, okay? Then there can be a left skewed data will also be there, okay? Left skewed will also be there.
So I'm slightly confused. I always understand what this skewness is, left and right, but I always get confused. The left hand side it is skewed, but we are saying it is right skewed. So that concept I always forget. I understand left to right skewed, normal distribution and all that. I very well understand, but I don't understand because it is leftly tilted. It is the distribution.
But we call it right
below the mean. But why it is called right distribution? Right skewed should be called left skewed.
Yeah, this is something that I was also calling this thing left for many a time, right?
Exactly.
But because it looks like all the data is on the left hand side, so we should call it left, right? But skewness, this is called skewness, okay? So skewness is on the right.
Okay.
Data is on the left, but skewness is on the right.
Okay, there's a big gap.
Right. So, so how to handle all these kind of skewness and what should we do in such cases and how should treat it, that also we'll try to explore it over. But question is, how can we identify the skewness? So to identify the skewness, the best way is what? Get the histogram plot, right? So let's say item weight dot plot dot hist. So this is something which is uniform distribution, okay? Thereafter, if I talk about sales, okay? So this is what? Right is skewed, right? So these all things we are going to understand in detail one by one and see how can we make this data better for later machine learning purpose, okay? So let's start with this thing, that is your fixing the issues in the data types, okay? So first we have the information over here. Okay, so let's start with one by one, right? So here I just had given you like what are we going to do. Now we will just pre-process the data, analyze and pre-process the data. Analyze and pre-process the data. Okay, so I'll take the data over here. Okay, so let's say what we had decided, we can just remove this thing from here, okay, or we'll convert this thing over here. So that we will do later on. Okay, first we need to check how can we fix the missing values, right? So if I will go with the missing values, let's say I know where is missing values. We have a missing values in two columns, that is weight and outlet size. Now let's try to handle the weight part. Okay, so shall I directly calculate mean and fix it? No, there are few calculations we need to do. Okay, what we need to check whether this column is having outlier or not outlier, because with outlier, if I will try to fix the missing value, it may be a wrong value that I may use, or I can use median. But it always good to identify the outliers over here. So how can we identify outliers? We can identify the outliers with the help of box plot, right? So let's take item weight dot plot dot box. Okay, so it shows we don't have any outliers over here, and item weight is also a uniformly distributed. Whenever you want to identify the outliers, you should go with two ways. Okay, there are two distribution, there are two plots you can use. One, it is called box plot, and other it is called what? Histogram plot. Okay, that means I can use over here histogram plot as well. Dot histogram. Now, can we just do these two things in one screen so that it will be more better for us, right? How can you do it? Very simple. See, here we can use subplots. Okay, there is a concept over here that is called subplotting. Okay, subplot in Matplotlib. So Matplotlib can be used for subplotting. Okay, so what is subplot? This thing is called subplot. Okay, or this is called subplot. All right, two plots in the same screen. Okay, in the same window, right? So how can you do it? Very simple. First of all, call your Matplotlib. We already called Matplotlib, but let me just use it once again. No problem. Okay. Thereafter, we will define over here plt dot subplot. Okay. How many plots you want? Okay. For example, let's say if I want these two things. Okay. That means I want a subplot like this, one row and two columns. Okay, so this is 1 cross 2. Okay, if I want a subplotting like this, that means it is what? 2 rows and 1 column. If I want a subplotting like this, okay, this is what? 2 rows and 2 columns. Right. So depending upon what you want, here I want 1 rows and 2 columns, right? So what I do, I'll just use over here 1 rows and 2 columns. Okay, so will it work? No, it will not work, but we'll see how it will work. Don't worry. Now I'll show this thing. So we'll see what error are we getting. We are getting an error. Subplot takes 1 or 3 positional argument, but 2 were given. That means here I can feed either 1 argument or I can give 3 argument. 2 I can't give. So what is the third argument? The third argument represents the positioning. That means if I want this kind of subplot, okay, I know I have to create 1 cross 2. But along with 1 cross 2, I should also give the position, like this is position 1, this is position 2. So first I have to give 1, okay, and second will be represented, first will be represented like this, and second will be represented by 1 2 2. First will be represented by 1 2 1, right, and second will be represented by 1 2 2. All right. That means here I have to give 1 to 1. Okay. And here it will be represented by 1 to 2. You get it? Okay. Now I want to increase this size. So it's very simple to increase. We can use your plt.figure figure size is equals to, we can define the width. Now what width? Width here you actually have to tune. Okay, you can just change it according to your own screen size, okay, and your own compatibility. Like I increase the height to 8, I want lesser height, so I'll make it 5. Okay, I want to increase the width, so width I want to increase, let me make it 15. Okay, all right. So according, so what are we doing? We are using Matplotlib for the first time. And why are we using? We are using it for defining the layout in which we want a plot.
Bipul, one quick question. The figure size you have said 15 and 5. What is like what is 15 and 5 actually? 15 is the size. What is 5? I'm not able to understand. Width. Okay. Height. Got it. Thank you.
Sir, 15 is what? 15, how many, what's the measurement? 15 milli something, or what will be the standard of measurement?
It actually presents the ratio. Okay. Like, yeah, right. Like for if I use 9 and 3, so
it will be smaller.
Like,
yes, if we want to encompass more graphs, then obviously we will shorten the width and the height. Otherwise, it will be too much. So if we are only using 2, then 15 to 5 ratio is absolutely fine. It depends how many.
The width will be 3 times the height. Okay, according to this thing, the width will be 3 times the height. Now, what value you have to give over here, that actually you have to tune. Okay, because according to, like, suppose according to the screen size, this will take the space. Okay, the screen resolution, right? So if I have still some space left over here, okay, and I want to just make it bigger, so I can increase this value. Okay, so now if I increase this value only, suppose I'm increasing only this value, then what happened? The height I didn't change, but height will be reduced. Automatically it will be reduced because I am saying that width should be 4 times the height. Okay, so I can just tune this thing like this. Okay, so you have to just tune it according to your system. Okay, so it will just take the space, whatever the space available. Okay, now whatever the plots we have, like this is a univariate plot, right? So I can use it over here, and this one I'll use it over here. So this is the overall figure, and in each plot what I want I had defined. Okay, so this is a content of the first plot, and this is a content of second plot. Am I clear?
Yes, absolutely.
So to explain this thing, I will make use of, that means this whole thing, that is your box plot and histogram. I will try to take one more example where I can have some other kind of distribution, because this is a kind of a uniform distribution. I just want to check if I have any data column in which we have some other kind of distribution, then it would be more explanatory. So I'll check over here visibility part. Visibility is left, it is right is skewed, right? We have any other thing, item MRP. This one also I'll take, but I just want to take the things. This is also uniformly distributed. Do we have any normal distribution? Normal distribution is not there, right? Quantity sold, it is also, I guess, right is skewed.
The second histogram is normally distributed, right?
Yeah.
The frequency, the second blue histogram is normally distributed. No, not this one. Yeah, the ones which are this one, yeah. This one is completely non-distributed. So
No,
something that
we don't have any normal distributed data over here.
okay,
Either it is uniform distribution, this is uniform distribution, or it is right skewed. We don't have any normal distribution over. No worry, whenever normal distribution will come, I'll explain. So now if you see both the things, let's focus on this part, that is your box plot. Let's try to understand the box plot over here. Okay, so what box plot actually represents? Box plot is used whenever it is uniform or a normal distribution. If it is uniform distribution or it is a normal distribution. Okay, within this range, normal distribution generally looks like this. Okay, here it is your mean, and then we have a distribution over here. Distribution means what? It is saying that if I talk about weight, so between 5 to 7.5, okay, between 5 to, you can see over here, whatever the samples we have, okay, it's like, let's say, between 5 to something like 6 or 7, okay, we have approximately 450 samples, okay, right? And between this one, that is your 7 to this thing, okay, that is close to 10. Between 7 to 10, it is approximately 850 samples. Okay, so it just helps us in understanding in which range how many samples are actually existing. All right. Now, whenever we have a uniform distribution like this or a normal distribution, in this range, we will have close to 99% of data exist. Okay, here it is 100%, but if even it is not 100%, then it will be almost 99%. All right. So if I have to calculate, then how can I calculate? See, below particular range.
So if it's uniformly and normally distributed, then the whole block plot will contain 95% of the data.
99%, almost 99%.
Uniform and normal, both.
Uniform and normal, right?
In both cases.
Right. So below this range, I have 25% of data. Below this range, I have 50% of data. Below this range, I have 75%. Okay, this is called quartile 1, this is called quartile 2, and this is called quintile 3. Okay, so quintile 2 we can also call as a median value. What we call it as a median value. Fair enough? So now if I'll check it out over here, that what is my quintile 1? What is quintile 1? Okay, so first I'm trying to analyze the box plot, right? So analysis of box plot and histogram plot is totally different. Okay, so first let's try to analyze the box plot, right? Analyze box plot. So this equals to your this guy plus dot quintile 0.25. So print Q1. Okay, so now it is 8.77. That means below 25, that means 25% of the data are having a weight value lesser than 8.77. Okay, and then if I will calculate over here quintile 2 and quintile 3. Okay, so quintile 2 and this quintile 3. So quintile 2 is 50% and quintile 3 is what? 75%. Okay, so that we can just print it over here. Quintile 1. Okay, quintile 2 and quintile 3. Anyway, this guy is not having any outliers, but just for understanding we're doing it. So you can say it is 8.77. This is the range, right? Maximum value is this is not a maximum value. This is just a kind of a 75 percentile. Okay, am I clear, Kaustubh?
Yes.
Okay, now what we do, we try to find out a range in which most of the data exists. So range of values within which most or you can say range of values, range of most likelihood values, right? Most likelihood values. Okay, that means a range in which most of the data is existing. Okay, close to 99%. Okay, so that can be identified by using first IQR. Okay, so IQR is equals to quartile 3 minus quartile 1. So this is called interquartile range. What it is called? This is called interquartile range. Interquartile, quantile, anything you can call it, range. Many people call it quantile, many people call it quartile. So this is 8.07. That means the difference between this thing and this thing. Now what I'll do with the difference? This difference will be calculated to, this difference will be used to calculate this upper boundary and lower boundary. Right. So this upper boundary will be equals to what? Q3 plus 1.5 times of this IQR.
Of IQR.
Okay.
Will be minus.
Calculated using Q1 minus 1.5 times of IQR. Okay. Let's try to calculate it. Upper fence. That would be equals to Q3 plus 1.5 times of IQR. Okay. Okay, and lower fence is equal to Q1 minus 1.5 times of IQR. Okay, so let's say print upper fence, that would be this guy. Sorry, and lower fence okay. So this is what we're getting. Now here I get a value minus 3, right? Isn't it? But here we don't have any minus 3 values, right? This thing is not minus 3. This thing is not minus 3, isn't it? If you will see this thing on a curve, it may be 3 or something. Okay. This is not at least minus, that is for sure. It is a positive value. Then how come this is positive if you have calculated minus? Because this is not the actual minus, this is a minimum value within the lower fence. This is what? This is minimum value in the data within lower fence. Okay, minimum value in the data within lower fence. Okay, so what is minimum value within the data? Let's say that we can calculate here. Okay, so for that, let's say I'll take over a DF of your item weight, right? Lesser than, sorry, DF of item weight greater than what? This value, right? So now I have true and false, right? Now I can filter it, DF of, based on this true and false, I can easily filter the data by passing this thing within this condition. This is a filter data. Now I can take the item weight, okay, again, and I can take the minimum value, right? So this is 4.55. So the mark that you see over here is actually 4.55. Okay. Same way, this is the maximum value within the upper fence. Okay. So this one is what? Minimum value in the weight column within lower fence. Right. And then we can calculate the maximum value within weight column in the weight column within upper fence.
So in this case, the item weight dot minimum will give us just one value which is above minus 3.34.
Correct.
Slightly on the blocks plot, not below the blocks.
Correct. Okay. So maximum value within in the weight column within upper fence will be what? It should be lesser than 28.96. Okay. I get true or false. Then I can filter the data. Data filtered.
Maximum.
Out of filter data, I can take the item weight.
The maximum. Dot. Yeah, no, not dot. Yeah. Item weight.
Then dot maximum. Okay, so it is 21.35. So upper limit that you see over here, 21.35. Okay, we don't have any value outside this range. That's why we can't see any dots over. You can see in the second plot we are seeing so many dots, right? But here we don't have any dots, right? That means we don't have any outliers over here. All right,
sir. But just one doubt.
Mm-hmm.
I know there are no outliers. At least in the blocks plot is not showing anything. But
Mm-hmm.
then what is 28 and minus 3? Isn't 28 a outlier? Which because we are finding one point below 28 to find out the Q3, and in lower fence it's minus 3, and then above the minus 3 which is like 4.55. So do you think 28 and minus 3 are the outliers, though they are not hundreds of outliers in the observation, only 2? I'm not getting this part. I understood the calculation, everything perfectly. What is 28 and minus 3 if this is the point that we already have?
Okay,
After
understood.
calculating the things, yeah.
Understood. Right. So let's say in your data there is a weight value 28. We don't have 28, but let's say we have 28, right? So 28 will be not outlier. Okay. 28.96. Okay. This will be the outlier. Okay. If we have suppose 28.96, we have 28.5. Okay. Right. So how box plot will be drawn? Suppose I have these two values and then we have 29 also. So how box plot will be drawn? Box plot will have this upper limit as 28.5. Okay, and 28.96 will be shown over here. 29 will be shown over here. All right.
Okay. So now my experience, now I understood what you're trying to say. So you are saying, okay, the blocks plot inside that has real values, but what the upper fence and the lower that we are calculating is not the point. It is just it's just the level.
Right.
To see if it is under and outside, then we will call it outlier or not outlier. It is just the number. So the actual value of outlier of the actual value is not 28 or minus 3. It is the limit that it is giving, and then the observations it finds out whether you have any outliers or no outliers. Correct. Now understood.
Right. Okay. So in this case, we don't have outliers and anything, right? So this is a quantile thing that we use. Now, what are the calculations for this histogram? Okay. So for histogram, actually, we need to understand the concept of a standard deviation. Okay. So he analyzes the box plot. Let's try to analyze over here the histogram, right? Analyze histogram. Okay. So here we will analyze. In this case, we don't have outlier, and then again we will analyze for this thing. Then we'll see the difference. We'll understand what it means actually. Okay. So for histogram, let's try to plot it once again. Okay. So histogram is having one thing over here, which is first we need to calculate the average value. Okay. So we'll calculate over here average value dot mean. Okay. So this is my average value. So this is what weight mean. Print weight mean. Okay, so this is my average value. Now what should I do with the average value? Let's try to put average value in the plot. Now how can you plot average value in the plot? Right. So directly using this we can't plot, we can't add. If I want to add few more entities, so we need to use Matplotlib. So now I'll do what? I'll use plt dot. You can also plot it through hist. Plt is what? Matplotlib. I am not importing it because I already imported it earlier. It's up to you if you want to import it or not. Matplotlib dot pyplot as plt. Plt dot hist. Wait. Why I'm doing it, I'll tell you, don't worry. Okay. Right. So we're getting the histogram plot, right? PLT dot. So now you may be wondering, like, if I can do it in single line, then why I'm using Matplotlib and all those stuffs. The reason being, I also want to add one more line over here, so that I'll add PLT dot axis vertical line. Okay. Where do I want to add vertical line? I want to add at x value is equals to weight mean. Okay. Color, let's say give it over here as what color I should give. Let's say I'll give it as a black.
Yeah, black is more clear, distinguishable.
Okay. So now it is what? Mean value. Right. Now we will try to find out the different range around it. The first range is called the range of first standard deviation. Okay. You have to find out a range that will be called as a first standard deviation. Now, what is a range of first standard deviation? Very important to understand. A range of first standard deviation is a range in which we'll get approximately 70% of the data. Okay, for a normal distribution or uniform distribution. Right. Let's check. So first calculating the for calculating the first standard deviation, we need to calculate the standard deviation. And to calculate the standard deviation, we need to calculate variance. Now, what is variance? Okay, let's say I will use item, this IW is equals to what? Item weight. So I just store all the item weight in IW. Okay, thereafter I'll do what? IW minus weight mean. So I just calculated the difference from the mean. Okay, I'm calculating the difference of each value from the mean. So for these values are negative because they are lesser than mean. These are positive because they are higher than mean. Okay, but they are negative and positive. I have to calculate average, right? So average I can't calculate if I have a combination of negative and positive values. Okay, because how can you calculate 3? It will becomes what? 6 plus 2 is 8 minus 5 plus 3 is again 8. So this will be 0, right? So average will not make any sense, isn't it? So what we do, we take the square of it. Okay. And then once we take the square of it, then we take the average of it. So this is called variance. Now, what is variance exactly? Let me just explain. First of all, let me calculate. So variance of item weight. Okay, variance of height. So variance actually is a part of measure of distribution. Okay, or measure of dispersion. Okay, like mean, median, mode is what? Mean, median, mode is measure of central tendency, right? And variance is what? It's a measure of dispersion. Okay, it is what? It is a measure of dispersion. In measure of dispersion, what we calculate? We calculate variance and we calculate standard deviation. All right. Now, variance means what? If the value of this variance is higher, okay, that means your data is widely spread around its mean. Okay, if the variance is lower, okay, when we have a variance lower, variance will be lower when your data is less spread around its mean. Suppose I have this kind of distribution. Here the variance is lower. Okay, but if I have this kind of distribution, here the variance will be higher. Okay, So it just represents how much your data is distributed. Okay, we get an idea of how much it is distributed around its mean. Am I clear?
Right. So yeah, so if variance is higher, that means the values are not very close to the mean. If the variance is less, then obviously it is more closer to the mean.
Correct.
Yeah. And similarly, the standard deviation. Standard deviation is the square root of variation.
Square root of variance, right? So let's try to put it over here. Okay. So what we can say, variance, we can say measures how far a set of numbers are spread out of their mean, okay, or average, okay, like, or how much the data values. And what is standard deviation? Standard deviation is like square root of variance, we can say. Okay, so variance is calculated by taking the square. So if I take the square root of variance, it will be what? Standard deviation, right? So here I'll calculate the standard deviation of item weight. That would be equals to what? Variance of item weight, or you can say np dot square root numpy dot square root of variance. Okay, print standard deviation of this one. Done. So 4.64. Okay, what it means? It means that if I will move 4.64 on the right hand side or 4.64 on the left hand side, so I will get the majority of the data, almost close to 70% of the data within this range. Okay, so let's see. I'll calculate the first standard deviation range. Okay, how can you calculate the first standard deviation range? Very simple. I will take over here the mean, or you can say lower fence, or left hand first standard deviation. Left hand first standard deviation will be equals to what? Your mean, whatever the mean you have. Where is mean? This is mean, right? Minus this thing. Okay, and right hand for first standard deviation on the right hand side, that will be equals to what? You will just take it and plus it. Okay, now if I'll print this thing, first a standard deviation range. This one and then this one. All right, now I'll calculate it, and thereafter I'll just put it over. Let's say AXV line, vertical line, and here it is 8.21. Okay, and here it is 7.50. Okay, so I'll make it, let's say, green. Axis vertical line, right? So this is a range in which majority of the data will exist. How much value will exist within this range? If I want to calculate, how can I calculate? I can easily calculate it like this. Let's say df of weight df of item weight lesser than 17.50. Okay, this is something which is lesser than 17.50, right? And at the same time, it is lesser than this thing, and it is higher than what? 8.21, right? That is the range that we have. I get true or false? No, I can just take the sum of it. So I have 4001, right? If I divide it by length of data frame over here, so I get 46, 0.4. Now you may think like, why it is getting 46? I told you majority. Because we have so many values are missing also, right? We have approximately a lot of these many values which is not considering at all, 1463, right? So that's why we are getting over here the things like 46. Okay, that means those missing values are not considered over here, isn't it? Now we'll go for the second standard deviation. So what is second standard deviation? For the second standard deviation, I'll just take this thing, paste it over here. This is what second. Yeah, second is, let's just second standard deviation. So I will just multiply 2 to this guy. That's it. Okay, and then I can just compare over second standard deviation range. This is your left hand side second. Okay, and right hand side second. So this is coming out to be 3.5722, right? So now if I'll plot it, 3.57 and then 22.14. Okay, so I'll make it what? Yellow. So within second standard deviation, generally we will have this one. Okay, so within second standard deviation, generally we will have almost 95% of the data exists within this range. 95%. Okay, but here it is 100%. Why it is 100%? Because it is uniformly distributed. Correct? If it is uniform and if it is normal, then it would be more. And within the third standard deviation, here we don't have any value outside second, but within the third standard deviation, mostly 98 to 99% of the data within the third. If anything outside third, we consider outliers. Okay, so here what is third? I just multiply with 3. Okay, this is third. Can we go for fourth, fifth? Yes, we can go for fourth and fifth also. But
generally it's up till 3. And can you also write the observation which you said? If it is uniform, then it will be under 2 standard deviation. If it is normal distribution, then it can be under 2, 3. That's something, and 98%, 95%, 70%. So that observation, if you can put that when we will revise it, we'll just remember.
Correct,
I do sometimes those small things you just tend to get.
So I'll put it. 26.79. Okay, I'll make it red. All right. So we don't have any value outside second. So this also gives us a generic idea that we don't have outliers over here. Okay. Am I clear?
Yes. So this we can do only in Matplotlib. We cannot do it in simple plots.
No, because so many, you have to just call it for multiple plots in the same way, right? Because if you go for the object-oriented plot, object-oriented means what? DF of item weight dot plot dot hist. Okay, so in that case, we can't use so many things.
And that dot plot hist is a part of pandas, right?
Right. That is called object-oriented plot.
So the simple ones are pandas, but if you want to make it more, more understandable, explainable, then and use subplots, two to 3 plots at the same time, or one plot having many things. So we will use plot Matplotlib. Otherwise, we want to just a simple plot, histogram, and this. Then we can use. Great. And we can write the observations also, so that we can.
Correct. Right. All right. So this is a situation. So in this case, we don't have any outliers, right? So as we don't have outliers, so we need not to worry much about filling up the missing values. Okay. So as you don't have outliers, you can fill anything. Okay. Like if I'll calculate the weight of it. Okay. Like weight, what is weight? Okay. Print df of item weight dot mean. I can use mean as well as I can use median. Okay, both are very close. So okay, right? I can use these things to fill the gaps. But one point we should consider over here. I told you about some sort of analysis. Okay, let me give a quick revisit. Okay, we had discussed univariate. Okay, in the univariate, what we did? We take the categorical column. If I have a categorical column and we are doing univariate analysis, then what we use? We use unique function. What unique function does? Gives us all the unique values in the data column, right? Isn't it? And what value counts does?
Just the complete count. It computes the complete count.
Of each event, right? Okay. Now, if I have a numerical columns, then we use what? Mean or median. Understood? Right? Now, I also told you about the bivariate analysis. If you see the last class thing, here I used bivariate. So what bivariate we used? In the bivariate, we had used both the columns categorical, right? Both the columns categorical, isn't it? So in bivariate, we had seen if it is categorical, okay, let me remove it. Bivariate, okay, if it is categorical, okay, then what can we use? Cross tab, isn't it? Using cross tab, we can find out how categories are appearing together. Clear? Understood?
Yeah,
right.
yeah.
Now, but suppose if I have one categorical and one numerical, okay, and then I want to perform bivariate, then what is it?
Or it will give an error. It will give an error because first we have to change the category or use encoders, into normal encoder, word encoder, and change it to 0 to 1 or f something.
Okay, see what I want to know over here. Let's say I have a weight values are missing. So I just want to check whether the weight is having some, kind of some good sort of variations according to item identifier. That means what is the average weight of food? What is the average weight of drink? What is the average weight of non-consumable? All right. What is the average weight of low fat? What is the average weight of regular? Okay. What is the average weight of item type? What is the average weight of soft drink? So it is a bivariate, right? Because I have to consider this column and this column, right?
Yes, sir. Yes, sir.
Correct. So in this case, actually we have to do what?
Change.
We have to perform grouping.
Grouping. Yeah.
Okay. So bivariate analysis we are going to do over here. Analysis when we have one categorical and one continuous. Okay. So what is categorical? Let's say average weights of food, okay, drink, and non-consumable. Okay. So how can you do it? df dot group by. Okay. Here we are trying to group based on what? Based on a particular data column, like let's say item identifier. Okay. Let's say based on this, I want to group it. Okay. So when I form the group, there will be 3 groups formed. Okay. From each group, okay, I want to pick over here item weight. Okay. So it will create 3 groups, and from each group I want to pick item weight, and thereafter the aggregation function. Okay, like for example, I want mean. Okay, so we have the average item weight of food, drink, and non-consumable, and they also seems to be very close, right? Isn't it? Compared to overall average, they are not having much difference, isn't it? Same way, let's say I want a average weight of what? Average weight of each type of fat content, right? Isn't it? So if I want average weight of each type of fat content, what can I do? Can I take it like this? So they are also very close to overall average weight. Average weight of each item type, isn't it? It is item type that we have. Okay. So these are the 3 things which may affect the weight. So when I'm trying to analyze them, they seems to be not much difference for at least for these 2 guys, isn't it? But here we may have some difference, like hard drinks are comparatively lighter compared to household and starchy food and all. Okay. So what are the solutions we have? Let's see. I have a item weight over here, item weight column, right? Now this item weight column, we had identified that this guy is not having any outliers. As these guys are not having outliers, we are sure that we can use mean or median. Okay. Now we are trying to understand how this weight is distributed. So we had over here, like say item type, sorry, item fat content. So for item fat content, the distribution is not that much. Okay. Then item representation like food or non-consumable, they are also close, right? So what are the options we have? Either I can use one, let's say mean value, to fill all the missing values. Okay, what is mean values? Mean values will be equals to 12 point something. It was 12 point something like this. Okay, so wherever the values are missing, suppose I will just fill with this thing. Okay, that is one of the solution I have. Okay, the second solution that I have is what? I don't want too much redundancy, because there are approximately 17% of the data is missing, right? So all those 17% information will be filled up with 12.7, right? Isn't it? So that may create a redundancy. That means data becomes so much redundant. A single value is there for 17% of the time. I don't want such situation. So what I can do? I can fill the missing values by considering where is it missing. If it is missing for baking goods, I will use this thing. All right. If it is missing for breads, I'll use this thing. If it is missing for breakfast, I'll use this thing. If it is missing for canned, I will use this thing. Am I clear? Are you getting my point?
Yes. Yes.
Yes.
All right. So now if I have to go for a simple approach, then what should I do? Please tell me. This already we did in last class. If I have to go for the simplest approach, okay, like suppose I have to fill with, okay, so let's try to do both.
Filna. So we'll use Filna and then in place
Correct. We can use over here, let's say fill all missing weights. Wait a minute. Okay. Okay. So fill all missing weights with average weight. So for that, what we do, we take this column df of weight dot fill NA, right? And then whatever the average weight we have, dot mean. All right. So this will calculate the average weight and will fill it. All right. Now this thing I can update it over here, but I will not execute it, right? Okay, this is just to make you understand that what can I do if I want to fill with this one. Okay, I'm not executing, right? But I want this thing. That means consider the item type, then fill the missing values, right? So how can we do it? What should be the process that we should follow over here? Clear? So let's try to think of the logic. Okay, now fill the missing values with the average weight of item type where with average weight of item type for the sample where values are missing. Okay, so we can do what? We can just pick it over here, df of I have to, okay, fine, let's have a data first, then we'll think of the logic, right? So let's think of the logic. So this is your data, right? I want to use this thing. Okay, so based on the average weight of dairy, wherever the values are missing, I want to use average weight of dairy. Fine. So while create a function that can return me the average weight of dairy. So let's say def, okay, average item weight. Okay, so to have the average item weight, first I require item type. Okay, and when someone will feed the item type, let's say if I call this thing, okay, and thereafter I feed the item type over here, soft drinks. This process I'm using it for the first time, so it may create a confusion for you, but don't worry, this process we will use for multiple times. Okay, don't worry about it. So now when I feed it, okay, like this, so this thing should return me the average weight of soft drink. Okay, if I will call it over here dairy, so this guy should return me the average weight of dairy. Okay, so how can I get it? All right, so we can get it like this. See, this is returning me the average weight of everything, right? Now if I will take it from here, okay, and then I will again use one square bracket, and let's say I'll pass over here seafood. So am I getting the value for seafood over here? Average weight of seafood, right? Isn't it? Now let's say if I just pass over here meat, so I'll get the exclusive average weight of meat, right? It means what? I can use this thing within this function, isn't it? And if I use this thing within this function, it means what? Here I have to just feed item type. I have to feed what? Item type. Clear? And then I'll say return this guy. Isn't it? So I'm asking to return this guy. Right? Now if I call it dairy, so am I getting the dairy average weight? Okay. If I pass over here soft drink, so I'll get the average weight of soft drink. Clear? Now the point is, what should we do with this function? This function we will apply Where should we apply? We will apply in this particular data column. Okay, so that for each row I will get a particular value. Okay, that means for the first row I'll get a value as what? Whatever the average weight of dairy. Okay, dairy average weight was what? Whatever it is. For the second row I'll get a value 11.84. Here let's say it is 12 point something. Okay, so for each row I'll get some values over here. Okay, am I clear? So let's try to do it. We are going to understand how can we apply a user defined function on a data column. Apply a user defined function on a data column. Okay, how can we apply a user defined function on a data column, right? So how should we apply? Let's take a data column, df of, what is it? Item type, right? Dot apply. Okay, what is this apply? Apply is an inbuilt function that can be used to apply a user defined function on a data column. Why we require apply? If I don't use apply, then what happen? You have to run a loop. Understood? Because this function can be applied at one value at a time. Right? Here you can either feed dairy, or you can feed soft drink, or you can feed something else. That means it can be used for one sample at a time. If a function, okay, if a function that can be used, okay, for one value, for one sample at a time, it means what? It means we need a loop to use function for all the samples. Okay, because for one sample it is working at a time, so we need a loop, right? So this apply thing is actually taking care of the loop. Okay, so in the apply we will apply this thing. So it will give me the values of each particular sample. Let's see what happened. Are it working? Taking time, huh? Okay, but finally it had given me the output. What is this? This is 13.42. Why am I getting 13.42? Because first sample is dairy. And what is dairy average weight? 13.42. Clear? The second sample is soft drink. What I am getting? 11.84. Why it is 11.84? Because average weight of soft drink is 11.84. Am I clear? We created a function that can take any single category at a time. Okay, and after taking a single category at a time, it will just return the average weight of that category. Understood? Okay, now instead of using, so how do we fill the gaps? We fill the gaps like this, right? This is how we fill the gaps, right? So here we pass what? Mean. So instead of passing the mean, we'll just pass this thing. So whichever, if I pass this thing, instead of passing a mean, what happened? Wherever the values are missing, they will only get affected. The existing value will not get affected. Okay. For example, let's say a sample number, if I'll just call it over here, let's say I'm calling only df. Okay. So in the df, is there anything where it is missing? Item weight, is there anywhere missing? Not missing, right? So okay, fine, let me just use dot head. Okay, let's say I'll call out df item weight dot is na, wherever the null values are there. Okay, and then I can filter it. So these are the locations where we have null values. We don't know about it. So sample number 7. So for sample number 7, it is not known. It is what? Snack foods. So for sample number 7, what is the value that we have? Let's say dot head. Oh, start executing once again. Okay, so first, just a minute. Okay, so for sample number 7, we have over 12.98, right? Okay, now as we have 12.98, it means if the value is missing for sample number 7, this will be replaced with what? 12.98. Am I clear? How it will be replaced with 12.98? Very simple. You have to just use dot fill na. Here, just use dot fill na, and this will only affect fill the missing values with average weight of corresponding item type. Okay, so now if I'll use it, it will just affect those guys where it is required. Okay, so in this case, we are avoiding the redundancy. Instead of using a single value every time, we are considering the type of item, okay, and their average weight we are using. So to do this, what we did, first of all, we created a function. This function will group by and calculate the mean of each group. Once we have a mean of each group, we are taking a specific item type that we pass as an argument to return the average of that particular group. Then this is a function ready for us. When we apply this function over here, it will calculate for each data sample. Now for each data sample we don't need, because for these sample we already have the values known, so we don't want to affect those. Okay, for these samples we already have the values known, so why do we change them? We don't need to change them. I only want to affect those samples where values are not known. So we will use this information not directly to replace the weight. This information can't be used directly to replace the weight. Rather, this information will be passed through the fill na, so that it can only affect those samples where the weights are missing.
Cool. And so sometimes we write in place is equals to true, in place is equals to false. So what is the logic? Because when we do not, it says false.
I'll tell.
Truth values are null. I mean, null values. Then we place in place equals to true.
Understood.
I'll
tell. In place is what? See, if we are using in place over here, true or false like this, right? In place is equals to true, right? So in that case, you don't need to write this thing. Okay? It will directly make the changes in the data column. Okay? That means it will replace with the null values and update the data column.
And what is the advantage or disadvantage of this?
No advantage. Just like if I don't want to use it, I can use in place. Okay. It just kind of, but nowadays in the current version of Pandas, they are giving the warning that they are going to
deprecate this.
Discontinue the in place thing. So there is no point. That means if you use it in coming version of Pandas, you may not get this parameter. It is just like this is to avoid using this one, right? Because here when we run this much, it is actually replacing the null value only for instance. We have to update it into the actual data column, right? So if I use in place equals to true, then I don't need to write this thing. This is not required. It will
sometimes there is a case where we do not want to update the data frame. We want to update this and keep it in some other data from D1, so that we separately treat the item. In that case, I think so. This is better in place of
Correct.
changing the data frame.
Correct. Right. If you want to add this information into a new data column or suppose a new variable,
so this is useful, more useful.
Right.
Yeah.
Okay. It is. So here we fix the missing values for the categorical. So Kaustubh, it is clear for you as well?
Yes, clear, but too many things, right? So I'll have to probably go again and take a look at it. But yes, whatever you've explained, it's clear actually.
Okay. So see, like it is very much related to what we did in last class. Like for example, here also we fill the missing values, okay, in the age column.
Yes.
Right. So here also we use fill NA.
Yeah.
Right. So when you use fill NA, we directly use the median value to fill all the gaps.
Correct.
Okay. So median value is just one value. That means here 19% values were missing. So 19% of the data samples got the same value, same age value. Right. So this sometimes create a redundancy in the data. That means one of the value becomes, too much.
Right.
Later on, machine learning model will learn more about a particular set of values compared to other set of values.
Right.
So just to avoid redundancy, we can use what? We can just try to calculate the average value based on a particular category. Right. So how do you calculate the average value based on a category? By using group by.
Correct.
Right. So group by is giving you this thing. Now I want to use, like, wherever it is baking goods, I want to replace with baking goods. Wherever braids, I want to replace with braids. Right. So for that, we created a function. Okay, here is your function. The function is doing what? Is grouping and calculating the mean of each category.
Right.
Okay. And thereafter, it is returning the mean of any specific category.
Right.
Okay. So now this function, to use this function, I have to feed an argument, but we have to use this function on a complete data column. So whenever you have to use any function on a complete data column, you should use apply.
Right.
All right. So it can be done. So now we have.
Before, just one quick thing. Can you briefly run me through univariate and bivariate? Because I'm still not gone through the last class recording. I was going, like, what is univariate and bivariate? Is like when you're univariate is like when you're trying to see the effect of one feature on the target, and bivariate would be like multiple features or like two features on the target.
Understood. Right. I'll tell you. See, univariate, let's say whenever we have a data column like this, I'll show you. Just a minute. Here I took the data, right? Now, if I am kind of targeting a single column at a time, okay, just a minute. Anyway, let me just explain here only, right? Why to go there. Why should I explain? It's okay, fine. Let me take, because this project I don't want to disturb, so I'll take a new file.
I'm aware of the Titanic dataset, Bipul. So you can tell me. I've worked on it actually.
Yeah, I understood. I'll tell. Just a minute. Actually, that file I don't want to disturb much. I just will explain here. Okay. So see, whenever we are going for the analysis, we have three ways we can analyze anything. Okay. One is called univariate, other is called bivariate, and third one is multivariate. Okay. So univariate is like we are just picking up a single column at a time to analyze. Okay. So when we are picking up a single column to analyze, it can be a categorical column or it can be a numerical column. Okay. So if I write over here, analysis. Okay, it's like univariate, and multivariate. Now, when I will pick the univariate thing, right? So it depends like what are we trying to analyze, because univariate done on categorical or it can also be done on numerical, right? So
Right.
univariate on non-numerical data. Non-numerical data. Okay. So non-numerical data, which one is non-numerical data? Like item identifier is non-numerical, item fat content is non-numerical. So what we do? First of all, we need to understand what is categorical, what is continuous. So for that, we done over here df. So when we run n unique, I'll get number of unique values in each data column. Okay. So here I have 3 unique values. Here I have 2 unique values. That it clearly shows that these are categorical columns.
Right.
Right. So if it is a categorical column, what we do? We use a function called unique function. df, we just take, let's say, item identifier dot unique. So this will help me understand that what are the unique values in a particular data column. So it shows that in this data column I have 3 unique values, right? And then if I want to identify like their distribution, like how they are distributed, right? Like so that I can identify that whether someone is biased, like is my data biased or not. Okay, just to understand the biasness. Okay, we can do what? We can just run over here value counts. Okay, here I can apply value counts. Okay, so we can clear says that my data is biased towards the food item, isn't it?
Right.
Later on, if suppose my model is built, machine learning model is built, and that is giving a higher accuracy for food item, we can say that because data is biased towards the food item, that's why we can expect a higher accuracy for food item, right?
Right.
Okay. Same way, let's say if I want the understanding of this thing, fat content. So I have 2 content over here. So I can use unique and value counts. Okay. So here it is not that biased. It's fine. Both of them are having good sample size. Biasness means what? One of the sample, one of the category is 70 to 80%, other category is just 20-25%. That is kind of a biasness. Okay. Now, same way, I can use it for item type. That is also categorical. All right. So these unique values and these are the distribution. Okay. Now this is called univariate analysis on non-numerical or categorical data. On
Right.
I should say categorical because categorical can be numerical as well. Okay.
Right.
Now univariate analysis on non-categorical data. Analysis on non-categorical data. So how can I have the univariate analysis on the non-categorical data? It's very simple. We can take any non-categorical data, let's say, which is non-categorical. Item weight is non-categorical. Okay, it is continuous, right? So we can do what? We can take over here df of item weight dot mean. So this is called measure of central tendency, right? So here I can analyze the mean. I can analyze what? Median, right? This is what? Or I can go for a standard deviation. I can go for variance, isn't it?
Right.
Same way, it's, let's say it is item weight. Other non-numerical is what? Item visibility, item MRP is there. Thereafter, other factors are there.
Right.
Okay, right. So this helps us in understanding that whether the mean and median is having a wide difference or they're very close. If they're wide difference, that means the chances of outliers are there very close. chances of outliers are less. So,
Got it. Got it. Thank you.
next, we have a bivariate, right? So bivariate is what? It's like taking multiple columns at a same time to analyze. Okay. Now, if you're taking a multiple columns to analyze at the same time, like how they are affecting each other, you can take two categorical columns, categorical versus categorical. Okay. Or you can take two continuous column, continuous versus continuous. Or we can take what? One categorical and one continuous. Okay, this is the pair that we can form, right?
Right.
Okay, spelling is correct. Okay, fine. Anyway,
Yeah.
so if I want to see over here, two columns that I want to pick, let's say item identifier and item fat content. Okay, let me have over here tf dot columns. Okay, so let's say item identifier versus so pd dot cross tab. Okay, df of item identifier, sorry, comma df of okay. So if you see, we have drink 728 low fat and 71 regular. Food, this is a distribution. Non-consumer are all showing low fat. Okay, so we will consume non-consumer anyway. Now we can do what? We can also use over here item identifier with item type. Okay, so we can say that in drink, how many item types are there? Drinks are having dairy products are drink, hard drink are drink, and soft drinks are drink. Food items, baking goods are food, breads are good. This one, okay, 542 dairy products are also food. Okay, hard drinks are can't be food, right? Soft drink can't be food. They are just thing. Non-consumable we have health and hygiene 520 and household we have 5910. Again, others we have 169. Distribution for each of them, right? This is called bivariate, like just to understand how different categories are related to each other.
Right.
Okay. Now we have, this is called categorical versus categorical. Now continuous versus continuous, right? So what is continuous versus continuous? Just to understand how two different columns are, continuous columns are related to each other. Okay, like for example, I have white item weight and item MRP. Okay, so for that, let's check item weight and item MRP. You can take actually multiple things as well. It can be multivariate. It can go up to multivariate as well. Okay, you can use by. So first, let's bivariate.
Right.
So now I want to understand how they are related to each other. Too, we can use what? Correlation. Okay, so this correlation shows that item MRP is not having much kind of a effect. But it is not getting affected much by the weight. All right.
Right.
Correlation is very poor. Okay, how correlation is calculated? So correlation you can just see like this. Correlation formula. So to calculate correlation, actually we use this thing. Okay. Now what is this? Let's try to understand. Okay. See here. I have x coordinate and y coordinate. Okay, now I have data distributed like this. Okay, now with this thing I also have something that is called mean of x and mean of y. Okay, so here this is your x, this is your y bar, and this is your x bar. Okay, now if I am calculating this entity, that means what I am trying to do in this region, x minus x bar will be positive because all of them are in more than its average, and y minus y bar will also be positive, right? So we are taking these two things for this section, right? Both are positive, so ultimate result will be positive. In this section both are negative. We have a value lesser than average value, we have a value lesser than average of y, lesser than average of x, so both are negative. So this will give you what? Overall negative value. Okay, in this case y minus y bar is positive but x minus x bar is negative. That would give you what? Negative value. And here it is positive multiplied by negative, so it is negative. So I have 4 sections. This particular formula will be applied in 4 different sections. Okay, in one section it will get positive, 2 sections it will get positive, 2 sections negative. But when you sum it up, more values are positive, then this numerator will be positive, because we have only, how many values are negative? We have only 5 values are negative. So most probably if you sum it up, if you are summing it up, it will be positive, right? Isn't it?
Right.
But if you have a data that is distributed like this, right? One of the entity is increasing, other is decreasing. So more values are negative, then this numerator will be what? Negative, right? So let's try to do this thing over here and check what it actually represents, right? So I am taking two entity. Let's say x1 is equals to item weight, okay, and x2 is equals to item MRP. Okay, thereafter I'll calculate x1 minus x1 dot mean, okay, and I'll just take the product with x2 minus x2 dot mean, just to understand how they're affecting each other. Now once I take it, I can sum it up. Okay, so when I sum this thing up, I'm getting a value 5523. Now this value will not represent the correlation strength, whether your correlation is very poor or whether your correlation is very strong. You can't get this understanding with this particular value, isn't it? Right? Because this totally depends on number of samples. Suppose if you are working on 10,000 samples, or you are working on 100,000 samples, or you are working on suppose 100 million samples, and this value will automatically get higher. Okay, so I want a kind of a normalized value which will consider the sample size, okay, and that can give you a value in a kind of a range so that I can decide. So we will use this thing in the denominator, right? So here we are trying to calculate the correlation considering the individual x and y squares. So final outcome will be in the range of -1 to 1. Okay, if it is close to 1, we can say strong. If it is close to 0, we can say weak, right? So let's try to do this thing. I'll use x minus x something over here. So this is your numerator. So let's
answer just one thing. Just one thing. I was slightly confused between when you made the x and y graph, and you I know y bar and x bar, it's fine. But in the first quadrant and in the first and the fourth quadrant, why it is minus? Why is the overall product negative? I think you deleted the.
Okay. I'll say. See.
First and the fourth quadrant, it was negative. So why we went to that?
Understood. I got your question. See, let's say I have over here x and y, right? So now my data is distributed like this. Okay, like this, right? I want to find out correlation, right? So what I do, I will have over here, let's say this is your X bar and this is my Y bar. Fair enough? Now X bar, this is Y. Now if I calculate X minus X bar, so all these values are more than its mean, right?
Yeah, X.
The difference will be what? Positive, right?
This is true. Yeah, correct.
Okay, and all these values are also more than its mean.
Yes, that's
In
positive.
terms of y minus y bar will also be positive, right?
Right.
Okay, so overall if you take positive this thing and positive this thing, the product will remain positive,
Right.
right? So if you sum this up, it will remain overall positive value, right?
Right.
So,
In this case,
people, just one quick question: Y bar and X bar, these are representative of the mean.
mean.
Okay, okay, got it.
Okay, now in this case all the y data points, that means all the y coordinates are lesser than its mean. So
Yes.
this is y, right? So all the y coordinates are lesser than its mean because everyone is having x and y coordinates, right? So y coordinates are lesser than its mean and x coordinates are also lesser than its mean, right? That
That's
means
right.
you are using what? Negative value multiplied by negative value, so it will be what? Positive, right?
Yes. Yes.
Okay, so that means these two coordinates will give you the positive value for the numerator. Okay, and these two coordinates will give you the negative value for the numerator, because in these two coordinates one of them is positive, other is negative. For example, in this case here all the x values are more than its mean,
That's right.
so x minus x bar will be positive. No, x value, no, sorry, sorry, all the y value is more than its mean. Okay, because this is y bar, so all the y values, all the y coordinates are more than its mean, so that is positive. All the x value is lesser than its mean, this is x bar, so that is negative. So negative multiplied by positive will be what? Negative.
Similarly, this.
Okay, same thing over here, one will be positive, other will be negative, so overall negative. So now, but we are summing up all these things in one. Okay, so
Yes.
if I have a data which is distributed like this, okay, the numerator will come out to be positive. If I have a data that is distributed like this, the numerator will come out to be negative, right?
Right.
Okay, and if I have a data that is being distributed like this, okay,
It's.
the numerator will come out to be close to zero, isn't it? Because we have almost similar number of sample for all coordinates, right?
Correct.
So numerator will come out to be close to zero.
Got it.
Okay,
Fine.
but
Understood.
that value on a numerator can't help you in getting the strength of correlation, because that is a sum, and the sum can be very high if number of samples are very huge.
Yes.
Okay, so we are taking this denominator so that we can normalize them in the range of -1 to 1. Okay, and then we can get the result. Like for that we are using x minus x mean whole square, and then we are taking what? Y minus y mean whole square, summing it up.
Correct. So,
Okay, so we just sum it up, multiplied by, and then we sum it up. Okay, we get the multiplication, simple multiplication over here, right? But thereafter we also take the square root of it, because we take the squared. Okay, and then we take over here dot, it is a square root, so for a square root we can take raised to the power 0.5, raised to the power 0.5, so we get denominator. Now with the help of it I can calculate what? Covariance n1 divided by d1. So this is 0.024, it is same that, oh, slightly different I'm getting. Why I'm getting 0.024? I'm using item weight, item MRP. Here also item weight and item MRP is there, right? It can be 0.025. I guess it has limited it to 1, 2, 0, 1, 2, 3, 4, 6, up to 6 decimal places. If I will also limit it to up to 6 decimal place, let me try. Round up to 6 decimal place. No. I'm getting 0.024. Here I'm getting 0.027. Something is not good over here. Item weight, item MRP, x1 minus x2 dot mean, x2 minus x2 dot mean. This is also correct. Then we take the sum of it. That is also correct. x1 minus x2 dot mean whole square and taking the sum of it. Okay. Then we put into one bracket. Then let me put into another bracket.
I think you have to close the bracket or something like that.
Yeah, just then I'm taking the square root of it. It can be 0.26 something, but this much difference is not possible. I must be using some formula incorrect. x2 minus x2 dot mean. This is the formula, right? x2 minus x minus x square, y minus y square sum, then product. I'm using sum and product, right?
Okay, so what is it doing is that they are not actually square rooting the whole equation. They are only square rooting the denominator and
Yeah.
then dividing it.
Yeah, so I also took the square root of this thing.
Yes, we did the same thing.
Denominator square root, I took it over here. Raised to the power 0.5 is a square root only, right?
Yes. Yes.
Something is not as okay. Fine. Let me do one thing. Let me try with one more thing, like item weight, item fat content, item MRP, item outlet. What are the other factors we have? Item weight. I took item MRP, right? Let me use item outlet sales as well. Okay, so just to cross check if. Okay, and then here it is coming out to be 0.56 between sales and this one, right? So I'll do what? X1 is equals to DF of item MRP. X2 is equals to DF of okay, and then I use the same formula 0.567574 567. Okay, here I am getting correct using the same formula, but here I am getting something different value 0.027141 0.025. How is it calculating? So is it incorrect? Which one? Like mine is incorrect or that? Okay, fine. Let me try for one. This is weight and sales, right? So I'll also take over here. Let's say weight and sales. Okay, for weight and sales, it is 0.014, right? So let's take weight. So for weight and sales, I am getting correct or not? 0.01155. So here 0. Okay, fine. So for this guy, we are getting it correct 0.567574.
Yeah.
574. But for all, like I'm using the
It's
same,
okay.
it is the same formula, but
Somewhere it's rounding off something, I guess.
yeah, rounding off is something which is creating the issue over here. Apart from that, it seems to be correct, but something is some rounding of item weight and MRP 0.027. Only three things are there. So out of these three things, this one is correct, but these two I'm getting slightly different. Not it is not very huge difference. It is just slightly difference. I'm getting a value. Weight and outlet sales. Weight and outlet sales. Let me take into 2-dimension form. But that should not affect, I think. Yeah, that is not will be calculated because it will be calculated like this only. X1 minus X2 mean, X2 minus X2 dot mean, this is also correct. Then we take the sum of it. Here also I take a square and then sum, square and then sum, right? So I'm taking a square and then sum, right? This is squared and then we are taking sum. That is also correct. Squared and then sum. It's fine. Slight difference is there.
It's fine. Yeah.
Some rounding up it is using, but that is a concept actually. Like inbuilt, this library may be using some kind of some slight changing. It may be applying according in the formula, but this is the actual formula using which we calculate it.
Sure.
So ultimately, what it represents how two data columns are affecting each other. Okay. So we had seen over here what the bivariate for continuous versus continuous. Okay. Now the last is what categorical versus continuous is what? It's like suppose I have categorical versus continuous. Okay. So let's say I have over here, I want to calculate average weights of each item identifier. So what I can do, I can just take the like categorical things are there, so that can be used for grouping, right? So df dot group by, okay, here I can take the item identifier, okay, right? It will group, and from each group I can take item weight, okay, and then I can take the average of it. So it is like creating a pivot table, right? If you want so many other factors to analyze in one go, so you can also use aggregate function here, okay, and in the aggregate you can feed the list of aggregation that you want. Like I want mean, I want sum, okay, I want, let's say, the what count, okay, I want minimum, I want maximum. So everything will be shown to you. Okay. So this is what we have, one categorical column using which we grouped and analyzing the other continuous column. Am I clear?
Yes.
Okay. So we'll just kind of conclude over here, and in the next session we'll go beyond this, right? I'll explain the concept over here using this distribution, okay, and thereafter we'll pre-process the data and we'll see that how can we implement it for the machine learning, right?
Sure.
So basic understanding of machine learning I may start in the next session.
Perfect.
All right. Perfect.
If you to ensure, okay, so first, this is a data we were considering. This is a data of BigMart. The data of BigMart is having few important features like item identifier, weight, fat content, visibility, item type, MRP. So these are the item properties, and these are our outlet properties, right? So we need to first analyze this data, and after analyzing this data we have to prepare it or pre-process it, and after pre-processing it we have to use for machine learning model development. So first phase is about analyzing. In the analysis process we'll ensure its quality, like we need to check all the data types, we need to check the missing values, we need to check outliers, multicollinearity, and skewness. So to ensure the quality issue, we started with checking the missing values part. Okay, over here, analyzing pre-process, where we started, I guess, where we started, data quality. So data quality, here we check the missing values, right? So in the missing values, we have few missing values over here. We need to fix it. But before fixing the missing value, we need to check the outliers. So for checking the outliers, we worked with box plot and histogram plot. So what box plot represents exactly? See, here I told you this represents the quantiles. Okay, like this is your quantile 1, this is quantile 2, this is quantile 3. Quantile 1, that means below this particular range, I have 25% of data. Okay, below this range, I have 50% of data. Okay, and below this range, I have 75% of data. All right, so these are the quantiles, and the difference between this quantile 3 and quantile 1 is IQR value, that is interquantile range. Okay, and with the help of interquantile range, we calculate the upper fence and lower fence. This is a formula for upper fence and lower fence. Quantile 3 plus 1.5 times of IQR and quantile 1 minus 1.5 times of IQR. This is the upper fence and lower fence. Okay, so within which, if your data is normally distributed or it is uniformly distributed, this is uniformly distributed. So if your data is uniformly distributed, this particular range will have majority of the data, almost 99%. Here it is total 100% data is within this range, no outliers. Then we try to understand histogram. So histogram we can have an understanding based on the measure of dispersion by calculating the variance and by calculating standard deviations. Okay, then we can calculate the first standard deviation range, and then we can calculate the second standard deviation range, and then we can calculate the third standard deviation range. Based on it, I plotted it, and then we can say most of the data, all of the data is within the second standard deviation. So this also proves there is no outliers, right? Thereafter, we have to fill the missing values. So for filling up the missing values, we can use mean or median. But if I use only mean or median, this can create a redundancy in the data. That means same value will be repeated for almost 17 times because 17% is missing values. So just to avoid it, we calculate the mean value for a category wise mean value, like drink average weight, food average weight, and non-consumable average weight. Okay, this is low fat average weight, regular average weight, and these are the item types average weight. So if I'm considering the item types average weight, I'm getting more values, more different values in the range of 11 to 13 or 14, right? So here what we calculated, that means suppose this is an average weight, that means first we grouped, and after grouping, when we take the average weight, right? So we want to use this average weight wherever the values are missing. Like for example, if for dairy product weight is missing, so I want to use what, this value. For canned product weight is missing, so we want to use what, this value, to avoid redundancy. So how can we get it? So this will give me the average weight of all the category. This is giving me average weight of all the category. We are taking one of the weight over here, one of the category, to find out the average weight of one specific category. We created a function over here. See where we created the function here. This function will do what? When you feed any category over here, this will return the average weight of that particular category. We applied this function on item type data column. When we applied this function on item type data column, we get the value for each row, but we don't need the value of each row to feed. We only want to affect where the values are missing. Where values are not missing, we want to keep it as it is. So this thing will pass through fill NA function. So we are using over a fill NA function, and we passed it. As we passed it, wherever the values are missing, those values will get filled up with the value that is being generated over here. So this is the thing that we did. Okay, and we'll continue from here. But before continuing from here, there was a question that you asked, but yesterday we didn't get time to discuss that, which is reading some JSON file. All right, so let's have understanding like how can we work with the JSON file. So first what I do, I'll create a JSON file. If you don't know what is JSON file is basically a type of data file, okay, which contains the information in key value pair, right? Like generally this kind of data files are called JSON files. Okay, in which we have a key and value. This is key, this is value, this is key, this is value, this is key, this is value, right? So let's first create a key value pair. Okay, so for that I'll do what? First I'll create a JSON file and then I'll try to use it. Okay, so I'll import a pandas. So in Python, which thing is which data structure we can use for key value pair? Dictionary, right? Dictionary can be used as a key value pair. So I'll define a dictionary over data is equals to, let's say, name. Okay, thereafter let's say age. Okay, and then let's say city. Okay, now here I will put some information. Let's say I will have over here Arun, Sanjay, Ajay. Okay, age I'll just feed over, let's say 25, 30 and 35. Okay, let's say city I'll just put a Delhi, Mumbai, okay, and Bangalore. Okay, so this is what we have. Now I'll convert this thing into data frame. So df is equals to pd dot data frame. Okay, data, right? And thereafter I'll save this thing as a JSON file. So for saving it as a JSON file, what we do? Let's say df dot to JSON. Okay, this is what saving as a JSON file, right? So let's say I'll give it a name people.json. Okay, and I can also use over lines is equals to true. Okay, what lines is equals to true will do? This will create a line delimited records. Okay, so let's execute it. I'm getting an error over here. Okay, orient is also required. So here I need to give over a orient. Orient is equal to any name I can give it, like records. Oh, it's orient.
What is this, sir? People.json.
Sorry?
What is this people.json, sir?
People.json is a file name. Okay,
Okay.
like we have created here. Okay, you can see this is a file that is being created.
Okay.
Okay, so this is JSON file that means now this file can be downloaded. Okay, right? So if I will not use lines equals to true, then everything will be in a single line. Okay, now it is in different lines because lines is equal to true has been used here. All right. Okay, next what we need to do, just a minute. Okay, next I have to read this JSON file. So for reading of this JSON file, we can just use over here. Let's say I can use an object or a variable. Let's say df JSON is equals to pd dot read underscore JSON. Okay, and I can feed the file name. Okay, like copy path. I'll feed the file name over here, right? And thereafter I can use df underscore JSON. Okay, so now it is showing some error. Elif content is split. Why it is showing error over here? Okay, let me just use lines equals to true because we have separate lines over here so that it can identify them easily. Okay, so this is how we can read a JSON file that we have. Okay, so can we have some sample JSON file? Do you have any sample JSON file?
No, sir. But I am why I was asking you, because generally the format comes in either JSON, either Excel, or either XML. And CSV in Excel is very easy to read, but especially in data engineering, and if you see the files mostly come in JSON. That is why I was asking how can we tackle JSON.
Right. So this is also a JSON file, right? This can also be JSON file, right? Let's try to create this as well. Say I have info is equal to this one. Okay. Now we can store. We will convert this thing into data frame. Let's say df2 is equals to pd dot data frame. I'll give info over here, right? So now I'll do what df2 dot to JSON, okay, and I'll feed over here info. No, not info. Info is already in df2. df2 dot to JSON. Here file name I have to give. Let's say people 2 dot JSON. Okay, so here people2 dot JSON will be created. All right, this is the people2 dot JSON. Now I want to read it, so I can do what df2 JSON is equals to pd dot read underscore csv. Okay, so I'll copy this thing. Okay, and then I'll see what df2 underscore JSON. So here I just created a JSON file and try to use it. But here, if I will see, the information is not as expected, right?
Yeah, so you have to write inline is equals to 2, just like you were saying, sir.
Yeah, what happened? It is not coming up as a tabular data, isn't it?
Right.
So last time it came as a tabular data, but this time it is not as a tabular data. Shall I use lines equals to true?
Single bracket, because it wasn't single bracket.
Yeah, what happened?
Because it wasn't single bracket, now this one is more listed, more nested one. This one is like nested one, and that was not nested. That was only under one single square bracket. It was like treating only one record. Now it's like multiple records in a nested file thing. So many curly brackets.
Yeah, right. So this thing is something which is not giving me the result as it is expected. So what we should do here, I need to check its. Now for feed read JSON and delimiter. Can I use delimiter is equals to comma or something? This is. Let me check once. Read JSON. I'll get some parameters over there. Let me try over here one more parameter, which is, I guess it's indent most probably. Anyway, let me just try it over here. So here, when I'm creating a JSON file, it can be, let me use orient is equals to records. Okay, and then I can also use over here indent is equals to 1. Okay, add tokenizing C expected 1 fills line 3. Okay, indent over here. Okay, indent can increase the, actually indent is used to increase this particular difference. Like here everything is having a lesser indentation. Now let me try it. Is it increasing? Indentation is increasing. Okay, yeah, indentation increased over here. Fine. Now I had given indentation equal to 4. Now if I try to read it, error tokenizing, here we are getting an error. It should read. It's okay. Fine. Let me check the explain error. This is this one. It's working good. To fix this, you should use p.read. Oh my god. Read JSON we should use. What I'm using. Yeah, fine. So actually, it is read JSON. I was using read CSV. That's why. Okay, fine. So if I'll do it like this, then also most probably it should work. Last time also it was correct. It was not incorrect. It was correct. Only problem was I was using read CSV. Okay. So now I can use read JSON. Okay. So if you have a data like this, you can easily read it. If you have a data like this, then also you can easily read it. Only here line indentation, that is that each information is a new line. That's what you have to define over here. All right.
Okay, okay.
Mhm.
Inlines, because here we here using something, sir. Here we'll use inline, and the second one we didn't use inline. Okay, here also we use inline.
Mhm. Because all the information is in new line, right?
Okay, yeah. So we have to
Mhm.
write it in another line. And sir,
Mhm.
another thing, when we are making machine learning models or for NLP deep learning, generally the file format will be what? It will be because I know in data engineering it is mostly JSON, but here in machine learning and deep learning, computer vision, generative AI and all. So what kind of file formats we will mostly get?
Mostly it will be CSV file only. Okay,
Mostly.
and yeah, but suppose someone had given you JSON file, then also we can read it, right?
Okay, we can convert it into a data frame, and
Mhm.
then we can use it just like as it was Excel or CSV. Proper. Okay.
Mhm.
Okay.
Mhm.
Save that JSON file also, sir.
Mhm.
Yes, yes, I will put that.
Just try it because JSON is to have so many variations, right? So just try with some other kinds of JSON file as well.
Actually, JSON has too much variations. Correct.
So just try with some other kinds of JSON file as well, and and just check if it is working or not. If not
Okay.
work, then please do let me know. Okay, we'll try to fix.
Okay.
Mhm. Okay, so now this file, let's get back to this file. Okay, and already executed. So what we did here, so we already had worked with missing values thing, but is it missing value completely treated? No, still we have a missing value. Okay, where is missing value now existing? Okay, so now you have missing value in outlet size. Okay, so what should we do in outlet size? Okay, that we need to understand. Okay, I'll also explain these things, but as of now, let's try to understand how can we fix outlet size, right? So first, try to read the outlet size column. Okay, so this outlet size column is having how many unique values? So these are the unique values. Okay, high, medium, small. All right, now we'll try to check their frequency. Okay, so for that, we'll take it and we'll use over here dot value counts. Okay, so now medium is most of the time it is medium. So now people do what? People uses kind of a mode value. In these cases, mode value is used. That means maximum repeated value, right? But I'll not suggest mode value to be used here because we have approximately 24. We have approximately 2500. That means 2410 values are missing. Okay. Now, if I will use this thing that all these 2410 values I'll replace with medium. Okay, so in that case medium will start dominating this data. Okay, medium outlet size will start dominating because medium outlet size will become, already it is approximately 2800, 2400 already you are adding, so it will be close to 5000 something like 200. Okay, so 5200 means what? Outlet size medium will create a biasness. Okay, that means later on when you will try to make a machine learning model, your model will be biased towards medium outlet sizes. Okay, so what can we do? We'll try to find out this outlet size is affected by which other columns. So we will see in the data what other outlet properties do we have. Okay, we can't just replace all the missing value with a single value. If I will replace all the missing value with a single value, that is median, which is maximum in number, my data will get biased, isn't it? So we'll check what are the other outlet properties do we have, right? So we have other outlet properties such as outlet identifier is there. Okay, we have outlet establishment here is there, outlet size, outlet location type, or outlet type is there. So these are the other outlet properties, right? That means what we try to do here, df dot columns. Okay, so I'll try to check the outlet size and outlet location type. I'll try to compare it, like how they are related to each other. So since it is a bivariate analysis, what can we do? Cross tab. Okay, last time what we did?
Cross tab.
Last time we did this thing. What? Group by. If you remember, we did group by because one was categorical, other was continuous.
If it is categorical, then
Right. So using group by, we grouped the data. That means based on categorical column, and then aggregate a numerical column. That we use mean for the aggregation. Here we will use cross tab because both are categorical. So we'll first take over here, let's say outlet location type, and then I'll take what? Outlet size. Outlet size, why are we taking? Because in outlet size we have values are missing. So we find that if it is tier 1 city, then maximum of them are small. Okay. If it is tier 2 city, then all of them are small. And for tier 3, it is medium, right?
yes.
Let's check with outlet type. So this is also giving me the similar, like grocery stores are all small. That means if outlet size is not known, okay, if outlet size is not known and we know it is a grocery store, so we can replace with, we can use over there small. Okay, if it is supermarket one, then also we can use small because majority are small. Supermarket one, majority of them are small. If it is 2 or 3, I can use medium because all the known supermarket 2 are medium and all the known supermarket 3 are medium, right? So instead of using all medium, we can use a smaller medium both, depending upon the information whether it is grocery store or depending upon tier 1, tier 2, tier 3. But out of these two options, which one should we use? Isn't it? So now we will also analyze these columns separately, right? We'll see like dot value counts because we have two options. We can explore more options, but as of now, we are exploring two options. So when I explore this thing, we find that in tier 1, we have 3,300 samples, tier 2, 27, and tier 1, 2,300, 88 samples, right? So this is not a biased information, right? Like all these three tiers are having almost close number of sample size. But at the same time, if I'll check this guy using value counts, okay, here we can see a highly biased situation, isn't it? Almost 5,577. Okay, if I'll calculate the percentage will be 65%. So 65% of the data are representing supermarket one, right? So it is a biased data, right? That means if I will use this particular thing, that is your supermarket or outlet type, suppose I'm considering the outlet type to fill the gaps in outlet size. All right. So I'm using a biased information, but in this case, I'm not using a biased information. So this is how you can decide which one to use, right? So here we can say that outlet location type we should use over here, okay, to fill those gaps wherever the size are missing. Okay, so let's try to implement it. We need to do what? We can use what? Outlet location type information to fill missing values in outlet size column. Okay, What we do, we can use outlet location type information to fill the missing values in outlet size column, right? It means what? See, uh, tier 1 and tier 2. Okay, in tier 1, majority are small. Okay, majority of outlet size are small, isn't it? And in tier 2, all outlet size are small. Okay, so in these two cases, we can use a small to fill missing values. Okay, in tier 3, all outlet size are small, so we can use it to fill missing values. All right, so let's try to create a function for that. So I'll create a function over here, def fix outlet size. Okay, and to fix the outlet size, what we required? We required outlet location type, isn't it? So we'll say that if outlet location type, okay, exist in what? Tier 1, okay, or spelling and space you should take care. It is what? Tier 1 or tier 2, right? Tier 1 or tier 2. It should return small. All right, then I'll say what? Return small. Okay, else in other case do what? Return medium, right? So this is a logic we build up based on our analysis. Now what we do, whenever we take this function and we know the outlet location type, let's say tier 1, so this guy will do what? Will return me a small. If I'll feed over here tier 2, I'll get a small. If I feed over tier 3, I'll get what? Medium. So this function is working properly, right? Now this function needs these information. Which information? This function requires these information. Okay, it will require this information. Okay, then only it can decide that whether small or medium to be used, right? That means the function needs to be applied one by one on each data sample over here. If there is a single function and I have to apply on each data sample one by one like this, so what are the options I have? Option number 1, I can create a loop, right? Like for loop or while loop. That loop will just go to each data sample and can find out what to be used. Or I can use what? Apply function. The second option is what? Don't use loop, just use the apply function. Okay, that I told you in last class. What is apply function? Apply function is an inbuilt function that can be used to apply a user defined function on a data column, right? So we will use what? Apply function. Okay, it is a inbuilt function to apply a user defined function on a data column, right? So it can be df of outlet location type dot apply. What I have to apply? This particular thing. So it will just apply this function on this data column and we get a small, medium and something like this. So this is giving me the information for each data sample, right? But I don't need information for each data sample, isn't it? Because for these data samples already we have information known, isn't it? Isn't it? Like for, like for these data samples, already we have the information known that it is medium, small, high, whatever it is. This is already known. We need not to worry about it. We need to check only those gaps where it is not known. Okay, where the values are not known, right? So I need to affect only those space where the values are missing. So what we can do? We can just check over here df and then outlet size. Okay, like this. And in this case, here the values are missing. If here the values are missing, okay. So if it is missing over here, then this should be replaced with what? Medium, right? Isn't it? The row number 3 values are missing, so this should be replaced with medium. Then row number 8519 values are missing, so 8519 should be replaced with what? Small. Okay, so wherever the values are missing, we need to fix those guys. So I'll use what? Dot fill na. Okay, dot fill na. You can see first 3 values are medium, it will remain medium. Okay, it will not become like this, right? So dot fill na and take this information and feed it over here. Okay, just focus over here. This will become medium and this will become small. Rest will remain as it is, isn't it? Others remain as it is. This becomes medium and this becomes small. Okay, so based on the new data column we created, considering the outlet location type, using a particular function, this data column will affect only those space where the values are missing, and then I can update our outlet size.
People, I have a question. Before you did the fill NA, you made that change, right? If you scroll up, right, when you said it will apply to everything, did it actually? Yeah. So did it actually change the data in the table?
No. This had just generated information for us based on the logic you defined in this particular function.
Okay, so
this function is
not
having certain logic, right? Yeah.
This did not change the data.
No.
Okay. All right.
This is not changing anything. What it did, this is a function you created. In this function, you have defined what? That if the location type is tier 1 or tier 2, return small.
Correct.
And if the location type is not tier 1 or tier 2, return medium. So now we are applying it on the location type column. So this function is checking each sample. Okay, like first sample is maybe tier 1 or tier 2. That's why it is returning a small. Second sample may be kind of a tier 3. So it is returning medium.
Okay, yeah.
Fourth sample like that. So it has generated it. Now this information is generated and for all the data samples.
Correct.
But in actual data sample, we have here missing value.
Right.
We have here missing value. Right? These values are not known in actual data sample.
Okay.
Right? So what will happen when you apply this thing in the fill NA? When you pass this thing in the fill NA, same thing. So only those space will be affected with these values where the values are not known already.
Correct. So people, people. So now in line 62 that you have put this in, right? Now does like what? No, it doesn't change the file. So the file is not getting changed by any means, right?
No. Here it is getting changed. Here, see, when you executed it, right? So this thing, see, this thing did what? Okay, fine. Let me just explain you like this.
Yeah.
See, here, suppose I have a data column called outlet size, right?
Correct.
In outlet size, let's say this is what we have. Okay. Now let's see. Here I have information known as a small, or suppose a small, or let's say sorry, no, what I did. Okay, let me draw one more time, no worry. So let's say this is my data column. In this data column, I have a information like this. Okay. Now let's say the first over here, it is medium. Okay. It is also, let's say, medium. Okay. Suppose this is also medium. Okay. This is, let's say, small. Okay. Now for this space, we don't know what it is, right? So when you will, but when you run this particular thing, this knows the outlet size for each data sample,
Right.
because this thing is giving the outlet size considering location type, right?
Right.
Okay. Location type is known for each data sample. Location type is not missing. So
Right.
as location type is not missing, this thing will generate the outlet size for each data sample.
Right.
Now this thing had generated, for example, over here like this: small, okay, medium, okay, thereafter let's say small, okay, let's say medium, okay, and let's say over here small. Okay, so this thing had generated value for each data sample. Now when you use fill na, and within fill na function you pass this thing, what will happen? Only that gaps will be filled up where the values are missing.
Right.
Okay,
Right.
the overall data will, like, this will not change, this will not change, this will not change, this
Yeah.
will also not change. Now this thing will just kind of fill the gaps, but after filling the gaps, it is not affecting the actual data. When
Okay.
it will affect the actual data? When we will assign it to that particular data column.
Got it. Got it. Now I
Okay.
got it. Okay. Okay.
So
Got it.
now we are here assigning. That means I'm saying that, okay, fill it. But after filling it, just overwrite the existing data column. So you
Oh,
just overwrite the existing data column.
okay. Got it. Got it. That's what my confusion. Like, why is it as changing the data set here and not above? Okay. Got it.
Right, right, right. All right. Fine. Okay. So now let's check if I have any other missing value. Df dot is na dot sum. I am not any missing values, right? Now let's do other pre-processing things. So now what I told you, here I have one more data column in which the first four characters seems to be same for all the sample. That means this four character we don't require actually, right? See, data analysis, data science is something that you can only learn by doing. Okay, I will try to consider multiple, like after this I'll try to consider some automobile data, I have a financial data as well, I have a healthcare data as well. We'll try to explore multiple kinds of data, and we'll get lot of different things that we'll do over there. Then only if I'll just try to explain theoretically that here in this case we'll do this, in this case we'll do this, so after some time we'll forget it, that's for sure. But I don't want to forget, so we'll just try to understand everything by doing it, right? So here in outlet identifier, is any problem? Actually there is no problem over here. Okay, we can use it as it is. But the situation is, if I will check the unique values, okay, so over here you can see the first four characters are same for all of them, right? It means that it is actually consuming extra spaces, isn't it? We just required over here 8-bit space, okay, because I have to store only two digits. But in actual data we have extra spaces, so that is not required. Okay, that is not required later on for machine learning purpose. For analysis it is fine. Okay, like suppose I have to just analyze, like what are the distribution of these guys, value counts, I can easily analyze it. Okay, I can easily analyze it, right? Or I have to analyze, for example, what is the sales in each outlet identifier. Okay, it is what, like, counts of each outlet identifier. Okay, now I want to analyze over here sales in each outlet identifier. Okay, so what I can do, outlet identifier is a categorical column. So it's very simple, df dot group by. Okay, group by based on what? Your outlet identifier. Okay, and then I can take the, once it is grouped, I can take the sales value. Okay, and then I can aggregate. So what I want to aggregate, let's say I want to aggregate multiple things, like I want to check mean value, I want to check the total, I want to check suppose minimum, I want to check over here maximum, and I want to check, let's say, count. Okay, so I can easily check it, right? Now here it is 10 to the power 5 actually. Okay, summation is very huge, that's why 10 to the power 6, so that's why you're getting it like this. Anyway, so now we get it like this. Okay, we have the information captured over here, minimum, maximum, and everything is there, right? So it is good that here we have multiple things like mean, sum, minimum, maximum. It would be good if at a time we'll analyze one thing, right? Let's say I'm analyzing only this one, right? Now once you analyzed it, you understand that when it is maximum and it is minimum. Okay, if you want it to be more intuitive, okay, more representative, right? So you can do what? You can create a bar plot, right? So you can create a bar plot like this. Dot plot dot bar. Or you can create more better representation by using heat map. How do we create heat map? For creating the heat map, we use a library called Seaborn. Import Seaborn as SNS. I created a heat map earlier. If you see in our last over here, I'll again just explain you. So here we created a heat map, if you remember, right? Okay. So similar to that, we can create a heat map here also. Okay, we can do what? SNS dot heat map. Okay, and then this one I can feed it. Right. So now if you see, I can use over annotation is equals to true. Right. So this is a value we're getting, but this value is not so much clear, right? So what I can do, I can use over a format is equals to up to 2 decimal places. Okay. So this we can understand that where it is maximum, where it is minimum, isn't it? We can easily understand here it is minimum. Now, if the size you want to be lesser, so how can you manipulate the size? How can we manipulate the size? Last class I told you. See, we can change the size by using Matplotlib, right? Isn't it? So here I can just call Matplotlib. Okay, and I want lesser width, and so I want, if suppose width only 3 and height I want, let's say 8. Okay, so plt dot so. All right, now it is looking better. Okay, you can increase or decrease as well. Let's say height I can increase it to it is more, so let's say 6. Okay, so this is how we can analyze. Okay, same way, whatever, like if you have to analyze it, so heat map can be used or this bar plot can also be used. Okay, for example, we have other factors are also there. Suppose I want to analyze item type sales value. Okay, item, because you have so many item types are there, right? So if I have to analyze item type sales value, what we can do? df dot group by. You got group by what? Your item type. So it will get grouped based on item type, right?
Yeah, then item outlet sales.
Right. And then I can take the item outlet sales. Okay, then dot aggregate. Okay, let's say mean, because mean and sum are mean will be lesser, sum will be very high, so it would be always better that you should do it separately. Now you can do what? You can also sort it. Dot sort values. So when you sort it, it will be let's say increasing or decreasing order. Okay. Fine. It is giving you error. What error is it? Let me tell you. So when I want to sort it, I have to give that I want to sort it based upon this column, right? That is a mean column. So that's the error it is showing. Dot sort values. Okay. By is equals to mean. So it is sorted in an increasing order. All right. If I want it in decreasing order, then I can use over here ascending is equals to false. Okay, so
False.
these are the parameters you should know. Okay, like sorting. So first aggregation I told you, and second sorting. And third, if you want it to be colored so that it can better represent it, right? So we can use what? Heat map. So I'll just copy that heat map thing from here. Why I'm using heat map? Why I'm not using bar plot? See, I can also use bar plot, but bar plot is something which is very common. Okay, and sometimes when we are presenting to our clients, or I have to give the proof of concept, so I need to create something different, okay, that other had not created or other people are not using, right? So this helps us in kind of a like we can say that I can also create a bar plot. Okay, like suppose this is a heat map. Along with the heat map, if I also want to create a bar plot, what should I do? Can anyone help me? If I want over here heat map is created, and here I want a bar plot. Here I want bar plot. So what should I do? Okay, like for example, what I want, this space we use for heat map. Okay, and this space I want to use for bar plot.
Yeah, there was another one where we created
Subplots,
two
right?
things. Yeah,
We can,
subplots.
yeah, we can get subplots, right?
Because
So here
Matplotlib, yeah.
Mhm.
Matplotlib, we have subplots.
Right? So here we can create over here, let's say subplot. So plt dot subplot. What should we do? Let's see.
1:2, and then one, and then the next one.
Right. And here I can use plt dot subplot 1, 2, 2. Okay. This thing, the same thing that we have up to here, I'll take it. Okay. This will group. Then we have sort values and
Dot plot. Dot plot.
okay, we can increase the size over here. Width I can increase. Let's say I'm making it.
It slightly came off.
So
Actually.
1 rows, 2 columns. Yeah, what happened?
3 rows came. Two rows.
It is correct, right? 1, 2, 1, 1, 2, 2. But it is showing error. That means it is not as per the expected outcome. I guess with the group by, this guy is not giving us the result. With the group by, this guy is not performing well. So what are the options we have? All right, no problem. We'll do something. Let's say I'll take it over here. Already we have this thing, right? So here I can give it a name. Item types average sales. Item type average sales, right? So here I can use item type average sales. Okay, and here, no, this will not work, but I'm just using it just to check if it is working or not. Yeah, so it is working, but I have to just make it better. So instead of using direct object oriented plot, so these are the things you need to check sometimes, because these are not your coding issues. Some libraries, over here SNS is working, but when I'm trying to do the object oriented plot over here, it is not directly working because we are using two different libraries, right? So here we can also use plt dot bar. Okay, plt dot bar, and here on the x-axis we can use this particular thing. Okay, in this thing x-axis can be this index value, right? So I can use dot index comma, okay, dot mean. Here we can use plt dot bar. This can be your x is equals to and y is equals to, shall I give, oh, not y, it's height. Okay, here in the error I can see still it is not working. What happened? It's working. Okay, so now it's working. Its height is required, and I should take the column like this. I was using dot mean, and mean is actually a keyword. That's why it was not working. But this guy is what overlapped on each other. So we can fix it by using plt dot xticks. Okay, rotation is equals to 90 degree. Right? That's why I said we can only learn it by doing. Okay, there is no other options. Okay. Generally, in one case, if I'm using normally, like I was not, like suppose when I was with this thing, I was using over here normally, okay, dot plot dot bar. It is working perfectly, no problem. Just one line. But when I used it in what? In a subplot, it was not giving me the result as expected, right? So it can give me the result as expected by using plt dot bar. Plt is what? Matplotlib, right? So when I'm using it in the subplot, you can see slight change I have to do, right? So when we do it, then only these kind of things we can explore. Okay, that is not working, then I can go it this way, right? So now it's working perfectly. Only thing that we can modify over here is what? Let's say we can just have the more width, let's say, so that it can be more, it should look more better. So now we have these informations identified in a single screen. Like let's say, let's increase this width more. Okay, so now it is looking better. So now we can easily represent this thing that starchy food is having a maximum average sales. Okay, then we have a seafood. So this thing is representing the bar chart, and this is representing their color kind of thing. Like if it is darker, it is lesser, it is like this, right? We can also set the color over here by using color map is equals to red, yellow, and green. YL for yellow, GN for green. Okay. So it is green, and when it is red, that is more intuitive, right?
Yes.
Okay. So that is how we can represent our information. So what I want to say over here, if we have a data like this, right, it is good for analysis. Okay, like same way we can analyze these guys like outlet identifier and can do the things, right? Like it is a bar plot, then we have this thing, right? Here also let me use the same color map, right? Color map is red, yellow, green. This is more better. Okay, so I'll use it, heat map, comma. Here I have not sorted actually. Okay, here I have not sorted. Without sorting, I can see the result. So we can represent it for analysis. It is good. Okay, but later on, if I want to use it for machine learning purpose, okay, in that aspect, these things is not required. Okay, because why I will let my system process extra information which is not adding any value. Okay, these 4 characters will not add any value while learning, right? As a human also will just focus on these things, so machine will also focus on these things, the things which are creating difference. So now we will try to learn how can we make the changes in the data values. Like if I have a data column given to us, right, and I want to change it, okay, for any one of our purpose, okay, like I have a data column given to, but I don't want to use this value, I just want to use this value, right? So we had seen how to identify the outliers, we had seen how to fix the missing values. Now we will see if any value I have to change, I don't want to use its original form, that is data transformation. Okay, you have to transform the data. All right, so here let's take any one character. Okay, let's see, this is my text, simple text operation. Okay, I want only last 2 characters, so there are 2 options we have. I can use print text. Okay, what is the index of it? 0 1 2 3 4. Okay, it is 4th index. So since it is a sequential data, okay, as I explained you, it is a sequential. Text is what? String is a sequential data. So it is a sequential data, I can use index, right? I can use this thing. Suppose I am not sure about this 4th index, I don't want to count it like this 0 1 2 3 like this, right? I want last 2 characters. So if I want last 2 characters, what I can do, I can also use over here sorry, I can also use over -2. So this will give me what? Last 2 characters, same thing. That means we know a logic how to pick a selected number of characters from a given text data. Now the point over it is how it can be used, how we can apply it on all the data samples. So to apply something, okay, to apply a logic on each data sample, what we can do? We can create a function for that. We can create a suitable function, isn't it? And once we have a suitable function, we can apply suitable user defined function. Okay, thereafter we will do what? We can use apply function to apply on each data sample. This thing we can do, we already did it earlier. So def fix what? This is something which is called outlet identifier, right? Outlet identifier. Okay, so here it is outlet, or you can say that just use identifier. Okay, and then we can use what? Return. What it gets to return? When you feed the identifier to this function will take the identifier and return the last 2 characters. So now I'll check whether this function is working or not. Okay, this function, to check it, I'll feed anything, let's say OUT, anything like this, whatever I want. Okay, let's say OUT, it can be anything. Okay, and then the number, right? So it will return what? Right? So now if I use this logic, right, in that case it will just start returning me from here 0 1 2 3, from here everything. Okay, if I use 4 colon, okay, then it will return everything, right? But if I just want irrespective of the length, I just want the last 2 character, right? So I can use -2 colon, but it is returning the value in a character form. I want it in a numerical form, right? So just typecast it. Now I'm getting numerical form. I have to apply this thing on a data column. What I can take? I can use item outlet identifier. dot apply this thing. Okay. So now we are removing the extra characters which are not required, right? And then I can just replace the, so is it like our actual data affected? Our real data affected? No, our real data is not affected. Our real data is remain as it is. Okay. If I want to update or overwrite my real data, it is what we can do. So this will just update my real data. Now I'll call it information updated. Am I clear?
Yes.
Sharing this file in the chat. Please access and let me know if anything you want me to repeat. Any part of it that you want me to repeat, just have a look and let me know. All right. So,
I have just one question on this file. So just the last one, like fix outlet identifier. You got that hexadecimal value somewhere, right? Like, how did you get that? That OUTXD. Like, I probably missed that step.
no, where I have used?
So you see 87. You did that, right? 87. So to apply the logic on each data sample. So there you said fix identifier, and in the function argument you put this.
Oh, fine. This is just for example. See, if I want to use this value, right?
Okay.
If I feed what it is in 13. So why we created this function? We created this function that when it will be applied on this particular column, right? So it will take the value from this column and return the last two characters, right?
Got it.
This is the purpose of it, right? So now I am just checking here. All of them are of 1, 2, 3, 4, 5, 6 characters are there. But I am checking in some case if it is not of 6 character.
Okay. Got it.
Suppose it is of more than 6 characters, then will this function will work or not?
Oh, okay, got it. Okay, all right.
So then also it is working. Then also it is giving me only last 2 characters only.
Okay.
That means this function we created is something which is working on any length of data. It will just give me last 2 characters. But if I will use this logic, suppose instead of 2 minus 2 I'll use 4. Okay, then for this kind of value it worked. Okay. When we have only 6 characters, it work, but it will not work for this case.
Got it. Makes
it
sense.
may not be why, but it should give me result. Why it is not giving me result? Okay, because I have used integer over here, right?
Correct.
Okay, so let's see. I'll remove the integer. Okay, so if you see over here, if I use 4 character, then from the 4th character onwards, everything it is giving me.
Got it.
Right? So now that's why I use this thing, because I don't want it to be length dependent. Whatever the length, it should return me only last 2 characters.
Got it.
And it should return me the integer value. So I'll typecast it.
Sir, can you explain it once again? Because I got the idea of I can read it, but sometimes I get confused between reading it from left to right and right to.
Yes, yeah. People, it will be helpful if you can explain that also. Yeah.
How
It's
to slicing.
Sure, sir. Slicing, I'll tell you. See, as it is a sequential, like text used to be a sequential data, isn't it? So it's like, suppose I have over here any text. Okay, let's say we Python is a fun language. Okay, now in case if I want to slice it, right? So I can use the initial index. Index starts from here 0, 1, 2, 3, 4 kind of thing. Okay, so suppose I'm giving over here 2. That means from index 2 it will return everything. This is index 2, right? Now in case if I want to decide that from index 2 I want, suppose, 6 characters. So 2 colon 2 plus 6. Okay, so am I getting 6 character over here? 1, 2, 3, 4, 5, 6. All right, isn't it? So this is something that we are doing from left to right. So left to right, index starts at 0, then 1, and then over here 2, right? But when we start from the end, okay, so it starts like this: -1, -2, -3 kind of thing. Okay, for example, if I'll use over here text -1, that means I am picking the last character. Okay, -2, last 2 character, -3, last 3 character. Or if I want only the last 3 character, I don't want everything, so just 3. So when I use -3, what I am getting? The -1, -2, this is -3. Okay, A is what? -3. So what is the difference between these two things? Here it is just the third character from the last. Here everything, all the characters from the last. Understood?
yes.
Yes. Okay.
All right. So this is done. Now, one more change that we'll do in data. Okay. Let's say here outlet establishment here. What I told you, outlet establishment here, again, this is a year, right? Now, if I have to analyze it, then it is good. Okay. Let's say I have to analyze it, df of outlet establishment year dot value counts. Okay, so we're getting the count. Like we can see that maximum outlet were established in 1985. Okay, and then how it is going ahead, right? So we can analyze it same way according to outlet establishment. Here I want to analyze the sales. Okay, so what I can do, pd dot group by outlet establishment year. Okay, and then I can take the sales over here. Okay, and then I can take what dot aggregate mean. No, sorry, it's df, right? Okay, then I can also use sort values. So value count is already sorted. Okay, dot sort values. Here we have to give it based on what? The mean column. Ascending or descending? I want ascending. So ascending is equals to false. Right? So maximum sales, obviously, because maximum outlets were still in 1985, so it is maximum average sales. But in 2004 is over here, 930. Okay, but it is having the next maximum, then this one, I can analyze it properly. Okay, so for analysis it is good. Or let's say if I have to consider few more factors. Okay, now let's check. We know univariate, we know bivariate. Now let's level up. Okay, go for the multivariate. Let's say I want to check over here outlet establishment year. Okay, and then I also want to consider outlet location type. Okay, and then I want to consider sales. Okay, so now if only outlet establishment here and outlet location type, that means these two are categorical column. Okay, so I can easily use p dot cross tab. Okay, what df of comma df of outlet location type. So I'll get like in which year how many, like in tier 1, tier 2 and tier 3 things are done. Okay, but I want to identify in each year, if suppose tier 1 is 528, 930 is this one 930. So the average sales of each, like in 1985, the average sales of tier 1, average sales of tier 2 and average sales of tier 3. In 1987, the average sales of tier 1, tier 2, tier 3. In 1997, the average sales of tier 1, tier 2, tier 3. Okay, that means it's a 3 column I want to consider. So what can we do? Okay, so to do this thing, let's check df dot group by. Grouping can only be done based on what? Categorical column. Okay, so I want to pick these two categorical column. So now it is what? This will create a hierarchy. Okay, in the hierarchy, outlet establishment here will be higher and this is a secondary. And then we can take what the column that we want to aggregate. Okay, so I want to aggregate the sales column, right? So let's say item sales. Okay, dot mean. So you get it like this. Okay, now sometimes this thing is not that intuitive. Okay, they're not that informative. Reading this thing is a little difficult. Okay, because it is a stacked. Okay, so after this we can use unstack. So when I use unstack, what will happen? This column will remain column. Okay, and this information will become the rows. Okay, and then this will fill the sales, right? Let's check. Okay, and then wherever it is not known, it is just n. So n can be filled as null value. Okay, so now we have information captured. All right, that is saying that in 1985 the it is from tier 3. Okay, in 1997 it is maximum from tier 1. In 1998 again tier 3. Okay, so this is what the information we get. We can make this thing look more better by using what? Heat map. I'll take one more example and heat map, and then after in the heat map I want annotation as well. True. Up to 2 decimal places I want. So format is equals to 0.2f. We know red, green, blue is working good. So color map I can use as what? Red, yellow, and green.
And why you've written filna dot filna bracket 0?
Fill now, or you can say fill in a bracket 0, because when I use this, okay, on a stack, okay, wherever, like suppose in 1985 there was no tier 2. Okay, 9085 there is no tier 2, so it is giving me null value. Okay, so that's why I'm using it, so that wherever the null values are, it can be 0. Okay, let's take one more example to understand this thing more better. The first time I'm going with the multivariate, so we need to take it, right? One more example. So let's say df.head. Okay, so we have an item type, okay, and item type, and then we have an item fat content. Okay, this is what we have. Okay, so now if I want to consider over here, let's say, okay, let's say item type and outlet type. Okay, item type, these two things I want to use. Item type, okay, and then outlet type. Okay, and thereafter item outlet sales. Okay, so if I only consider item type and outlet type, it will give me what? That how many items, which items are sold for how many times in each outlet type. Like I will use cross tab. Okay, df of item type. Oh, df of outlet type, right? So it is saying me what? That baking goods. Okay, baking goods are maximum sold from supermarket 1. Breads are maximum sold from supermarket 1. Okay, we get it like this, isn't it? This is just bivariate. Okay, we can make it more intuitive by using heat map. So SNS dot heat map. Okay, annotation is equals to true. Okay, format is equals to point 2f. Color map is equals to red, yellow, green. Okay, and size also I can increase. plt dot figure. Figure size is equals to, let's say, 8 cross 8, and then plt dot show. Okay, this is what we get, right? But suppose let me just do one thing, decrease the height over 8 cross 4, because height becomes too much. Okay, and width, let's say to be 5. Okay, so you get it like this, right? But here it is just representing the count. Okay, it is representing what? The count. What I want the sales figure also, sales figure to be present here. What I want sales figure. That means each item type, in each outlet type, like each item, like baking goods in grocery store, what is average sales? Okay, here I want average sales value. Total number of baking goods sold is what? 85. Okay, since it is an integer value, we don't need any kind of decimal. Okay, so baking goods sold was 85 in what? In grocery store. Okay, so most of them are having a higher sales in supermarket 1, right? Like this. But here I want the average sales. So how can I have the average sales? Right? So to have the average sales, we know we have two categorical column. So we can just take it df dot group by. Now we have to decide which one to keep as a first hierarchy. We have two categorical column. Which one to keep as a first hierarchy? Okay, let's say I am keeping over here, that obviously we can change outlet type as a first hierarchy, that is grocery store and supermarket 1, supermarket 2, like that. This is the first in hierarchy. And second thing that I want to put in hierarchy is item type. Okay, this is second thing I want to put in hierarchy. Okay, and thereafter I can take the sales, right? after grouping item, outlet, sales, right? Okay, and then the aggregate function. Let's say I want to calculate mean. You can also use sum and all. So now the output that you are getting is what? It is stacked. Okay, it is what? It is a stack on each other. First, I have a super grocery store. Then below this grocery store, there is a supermarket 1. Then maybe supermarket 2. Then maybe supermarket 3. Like this, right? Isn't it? All the informations are stacked. Okay, that's why as it is stacked, we don't get all the information clear. This is what? This is exactly the pivot table. Have you created pivot table in Excel ever? No?
Yes.
Yes, sir.
Okay, if you have not get it, then also it's fine. It is actually the pivot table, right? So now if I take it and I'll do what? Unstack. Okay, so stacking will be removed and proper table will be created, right? So here we have the exact figure that how each average value of sales for each of them in each. So here we don't have any missing values. That means all the items are sold in all type of outlets, right? So if suppose there is an item, like suppose meat is not getting sold in supermarket 3, so I'll get null value over here. So null value means what? It is 0. That means it is not sold there. So that's why we use dot fill na 0. You understood why do we use fill na? Because here we don't have any missing value, so no fill na. But here when I execute it, in this case, right? If I just executed it, right? In 1985, there was no information about tier 2. Okay, so that they were creating a null value. So I'm just filling those null values with 0.
Right.
All right. Okay. So now it is what we get. Now, you know, if I get this thing and I want it to be more intuitive, I can use what? Heat map. So I can just take it. Okay. And thereafter, I can take it. Okay, so this is something which is not very much clear. Okay, how can I make it clear? I can make this thing clear by increasing the figure size, right? We have width I can increase, let's say 20. Okay, so if I present this thing to anyone can easily understand what's going on, isn't it? Which item is getting sold where, how much? Are you getting it, like how multivariate analysis works, and at the end what is pivot table and how can we make it representative? Yeah. See, if you practice it, it's very easy, nothing to do. Okay, if it is one categorical, one numerical, group by. If it is both of them categorical, cross tab. Then hierarchy also we can create. How can we create hierarchy? By using by putting
categorical and one numerical.
By putting multiple things over here. Okay, two categorical things. Then this will be first in hierarchy. This will be second in hierarchy. Then it will create a stack like this, stacked information.
Then you stack it and then you do
right. So this is first hierarchy. This is second in hierarchy. These are the values. Then unstack will convert them into a proper table. Okay. So you know it's like you can just try to do the same thing. Let's say if I want to do over here. Okay, let's say I want to use over here outlet size, location type, and quantity sold. Can you just try your own and share the thing into the chat? What should I do? If I want to create a pivot table using these two columns.
group by two categorical variables, and then
Right.
just mention, and
Right.
then write. Then when you write the logic, then you write just
Aggregation function.
heat map, and then at the end stack, unstack, and if there are too many zeros, then you write filna 0. That's all.
So, DF dot group by. Group by based on what?
Outlet size and then outlet location.
Outlet size, right? And then we can do the outlet location type. Okay. And thereafter,
then quantity
this
sold.
will create a group. Now from each group, I want quantity sold.
Quantity sold.
Okay. Now here I want the total quantity sold. I don't want the average.
Then
so instead of using
then sum.
mean, I can use sum.
Then you can use sum also.
Okay. So get it?
People, what is
So this is what?
people?
This is creating a hierarchy.
Yeah, it is not looking good.
But
understand.
Yeah, but if you see in high, we have only tier 3.
Tier 3.
That means if I will unstack it, it is a stack. If I'll unstack it, I'll get null values for tier 2 and tier 1. Because here in high, I have only tier 3.
No values.
So it is getting null value for tier 1, tier 2, right?
Fill 0.
So I can use dot fill na 0. So step by step, you don't have to memorize this whole syntax in one. Okay, no need. You have to just execute. You have to first go for grouping, then adding, then considering a particular column. Okay, and thereafter doing the things.
Then we can also round it also, because this 0 0 does not look good. So we can round it to this, we can remove to 0.
Yeah, we can round it as well. For rounding up, what can we do?
I think round is a function.
No, dot round will not work. I don't think that will work. No, it's not working.
Because this 0 0 will be too many if in some case. We have to round it
Yeah.
up.
Can we convert this thing into integer using as type integer? Yeah. So as type will convert each value into integer. Integer will be what?
So before it was not integer?
No, before it was decimals, because decimals was there, right? So that means it was actually a float. It was a float, right? Because decimal is there, right? But when I did it, it converted into integer. Integer don't have a float values. Then the integer don't have a decimal values.
Okay, in case there are decimal values, like for example, which are important, but we do not want to take all 5 decimal values. We just want to take 2, round it to 2. Then how will we do it in that case? Because here,
Okay. Like this, right?
yeah, we just want 2 rounded to like 86. Then it is 0.89.
All right. So, over here, see, in the heat map, it can be done easily. Okay. Like using format. Okay. Up to 1 decimal places. Okay. But if I want it in a table, okay, like suppose in this table, I want it, right?
Right.
So what should we do? So if I use dot as type,
it will only remove the
integer, it will just make this integer. So obviously this is not expected, right? So in that case, let me think. If I use dot round up to 2 decimal places, then it will work. All right.
Right.
Okay, round will work, but you have to just define how many decimal places you want.
Exactly.
So this is a table, and this is a more better representation of the same table.
Right. Correct. Yeah, this is slightly looking better. Sometimes it does not look good, but this time, since it's in a rectangular shape instead of I don't know which shape is that, but this shape is better. Tabular form, it's looking better. Otherwise, if it would have been vertical, it would have looked very bad. Then you would have not understood what it is. This way, it's you can understand.
Yeah, like you were saying this thing.
Yeah, sometimes, right. The vertical heat map.
This one you're saying, right?
Yeah, I don't understand that.
So this one also you can convert into horizontal form. Let me try. Let's say if I want in a horizontal form, so what can we do? Let's say this is the outcome. Can we how to convert this thing?
Suppose, no.
Dot T will work, yes. Dot T is working, it's transpose. Okay? And once it is done, you can use it. Okay? Dot T actually we use in numpy transpose, but here I just checked, like I have not used it earlier. I just checked whether it is working or not, but yeah, it is working. But we have to just fix the shape of it, right? So let's say plt dot figure size. I need width to be more. Let's say width is 10 and height I want just 2. plt dot show. Okay, so we can increase the width more. Let's say I'll make it 20. Okay, so I'll get it. Now here I'm getting 10, 13 because OUT0 we have removed, right? Okay, if I'll just run it once again. Now it's better?
Yes. Right.
So you can easily transpose it and then you can pass into the heat map. You get the result, right?
Got it.
Okay. So now this thing is done. Okay. So we had seen these analytical things, right? But what I was trying to tell you, see, now the point over is if I have a data like this, okay, so for analysis purpose, this information is fine. But later on for machine learning purpose, this information we may required over here the age of age of any particular outlet. Why age is required? See, if I will use age, so what I do, I'll use the current year minus the establishment year. Okay, so it will give me what? A output which will be a 8-bit information like this. Okay, but this is not a 8-bit information, this is 16-bit information. So right now this is using more resource to store the data values. Now for single sample this will not affect a lot, but suppose if you're working with a very large scale data, okay, like suppose millions and billions of samples you are working, so in that case this small 8-bit and 16-bit will create a major difference. Okay, so you will require more amount of data to store, as well as processing will also be slower, right? Because obviously a system can process the 8-bit data faster and it will process the 16-bit data slower comparatively, right? So machine learning, when we are going to use, we will always try to kind of transform our data so that the magnitude can be as lesser as possible. Okay, so for here, instead of using year of establishment, okay, we can make it what? Age, right? So how can I have the age? The current year minus this one.
The establishment year.
So I'll get it. Okay, so this is the age of any outlet.
Bipul, by transforming outlet establishment year to age, are we transforming the kind of data, because year would be categorical, right? but age is a continuous type of. So that
Correct.
right? Okay. I just want to kind of get that clear.
Yeah, right. It will be a continuous in nature. Okay. But the information remains same, right?
Yes.
In the data information, we are not kind of
Correct.
affecting.
Yeah.
Just instead of using the year, we are using the age, because ultimately for machine learning we require information.
Correct.
So,
Makes sense.
right. So now we have this particular information, right? You can also try with here. It's not incorrect. Okay, it's not that if you use this information for machine learning, I'm not saying that is incorrect. It is just about resource optimization. Okay. Suppose by using the year over here, you are getting a better accuracy. By using age, you are not getting better accuracy. So in that case, go with the year only. But that doesn't happen. You'll get the same accuracy whether you are using year, whether you're using this age. We'll check that. Right. Now we have this information calculated. Now we have to understand how can we add a new data column into the existing data frame. Okay, already we have existing data frame. In the data frame, we have calculated from this given information. The lot of time it happens from the given set of information, you generate a new information. Okay, from the given set of information, you generate some new information, and then this information you want to put into the data frame. Okay, for example, let's say you had been given a sales. Okay, and then you had been given a quantity. This is your total sales, and this is total quantity. Now I want what? Sales value for each quantity. So sales value for each quantity, what you have to do? You have to divide it. Then you can get the sales given set of information. So that is very simple. Okay, any kind of calculation you can do within the data columns, like I did here. Okay, here if you divide this item outlet sales by quantity sold, you can easily divide it. Okay, like for example, if I take it over here, df of like this divided by df of, it will be the element wise operation. Okay, for each sample it is divided, like first 3735 divided by 14, this will divide by 9. So this kind of operation we can easily do, right? But the point over here, once we did this information, how can we put it into the data frame? All right, so we're putting it into data frame. Okay, let me create a new data frame over df1 is equal to df.copy. Now I don't want to change the original data. Let's say df1. I want to put it. So I will decide where should I put. It is index 0, index 1, index 2, index 3, index 4, index 5, index 6. At index 7 I want to add. Okay. So what I do, we'll use df1 dot. I don't want to change df anymore. Okay, so insert function, and if you see insert function, what are the parameters? The first parameter that you can see on your screen, it is location. I want at index 7. Thereafter I have to give the column name. So let's say the column name is outlet age. Okay, and then the value that we calculated. So what we are learning is existing data frame. So it is being added over here. Okay. Now, as it is added, I don't need this thing anymore. I don't want it, okay, because both are the similar invite. I don't want it. So as I don't want it, what we will do? I can just drop it. df1 dot drop. How do we drop? Columns already the dropping I told you with the Titanic thing. Okay, right. So you can just give a list of all the columns that you want to drop from here. Is it dropped from actual data? No, it is dropped only for this instance. Now I can update my actual data. Done. So I have an outlet age instead of outlet year. Am I clear?
Yes.
Now, see, after this, I had planned you to tell you this distribution, but as of now, I'll not tell you because I want you to understand why this information, why this kind of distribution needs to be fixed, okay, and what is the effect of these kind of distributions, okay. Here, if I try to explain, you may not be able to understand properly, so I want it to explain now when I will explain you the machine learning part, and I'll actually show you the difference, that what happen if I use the skewed data and what happen if I use the normal data. Okay, I want to show you the difference, then I will explain this part. So as of now, just keep this thing as it is. We'll get back to this thing. So now I have a data prepared. In this data, I have an item identifier, I have an item weight, I have an item fat content, visibility, item type, MRP, outlet identifier, outlet location type, and these all things. Okay. Now I want to use this thing to build a model which can predict the sales. But for building that, I need an understanding of machine learning. So let's start the machine learning concept over here. Okay. Machine learning. Okay. So now today I am starting the machine learning. Obviously, I'll go in more detail in the next class. But for today, I just want to start it so that you will have some time. Okay, one more thing, during the weekdays also, if you want any kind of assistance, any kind of help, suppose you're going through a topic, you want to have some sort of small meeting to get your doubts clear, you can reach out to me, right? You can just let me know, and I'll like if I have some spare time, I can schedule some doubt clearing session in the weekdays as well. It's not like that in weekdays I'll not be available. Whenever you want, I'll try to be available, right? So we will deep dive into the machine learning things, which is like supervised learning, unsupervised learning, okay, and reinforcement learning. Okay, so let's try to understand these things one by one. So we'll take over your whiteboard. Okay, so machine learning, okay, because ultimately when we are preparing our data, why do we prepare our data? With the data we can do few kinds of analysis. One is called descriptive analysis, that will just describe your data. Okay, that descriptive analysis, how do we perform? We perform with the help of mean, median, mode, right? Plotting data, plotting data, you can describe. Then we go for predictive analysis, which we want to predict something. Okay, so that predictive analysis can be used with the help, can be performed with the help of machine learning. Okay, and once your machine learning model is prepared, we do what? We monitor that model, we evaluate that model, and we'll try to understand how that model is considering each features. Okay, like suppose I build a model over here to predict the sales. Now I also want to check how that model is considering each factor, like how it is considering item identifier, how it is considering item weight, how it is considering item fat content, like each feature, how it is, like which feature has been given a higher weightage, which feature had been given a lower weightage, which feature had been given a no weightage, right? To decide the sales, right? What are the weightage of each feature, how actually algorithm picked them, how algorithm used them, right? So that kind of analysis we do to prescribe something, and that is called what? Prescriptive analysis. Okay, so people generally get confused, like between data science and data analysis and machine learning. Everything is so much stitched together, right? Everything is so much stitched or depend upon each other. Like many a time you can't differentiate it, right? Data analysis, there is no machine learning, right? And for the machine learning, you require data analysis and data science. And machine learning is also one type of analysis. Okay, it is also one type of analysis which we can say as a predictive analysis kind of thing, right? So
prescriptive analysis, what we use for prescriptive analysis?
For prescriptive analysis, we will analyze our model. Like when our machine learning model is formed, that means a predictive model is formed, right? We have a predictive model which is predicting something, right? So we just analyze that particular model, that how that model is, what that model is doing, what kind of weightage that model is giving, that predictive model is giving to each of the features to predict something. Okay, like for prediction of sales, okay, what is the weightage given to MRP? What is the weightage given to item identifier? What is the weightage given to age? So that we can prescribe some changes. Okay, one more example. Let's say there is a company, right? And that company is running some advertisement. Okay, advertisement, let's say they are running on social media. Okay, they are running on advertisement on TV, and they're running advertisement on newspaper, right? And then they are just monitoring their sales. Okay, so that company actually don't know that which particular advertisement is affecting the sales more, because they're just monitoring the cumulative sales, the final sales, right? Isn't it? So as a predictive analysis, what we do? As a predictive analysis, we'll try to use these informations, okay, and this information to build a system so that in future, if company had decided their budget, then we can just predict that what can be the sales value. Okay, in advance we can give the figure that if you have this budget, then this will be the probable sales value. Okay, that is predictive. Prescriptive will check like this sales values is getting, like while predicting the sales value, which factor is more important? Is it social media which is actually playing the more important role? TV is playing the more important role, or this guy is predictive playing the more important role? Suppose the sales value, okay, is highly dependent upon social media and TV. Okay, that means only TV and social media is something which is affecting the sales. This guy is not affecting the sales much. So what can we say? We can give a prescription that newspaper, whatever the expense you are making on the newspaper advertisement is not affecting the sales. So you can decrease the budget for this guy, right? Because it is not affecting the sales much. That is prescription, right? You can do it after building up the model. You can do it before building up the model also, like for example by using correlation. Okay, if I try to find out the correlation between this, okay, and I find the correlation between social media, the correlation between social media and sales is, let's say, 0.8. Okay, correlation between TV and sales is, let's say, 0.5, and correlation newspaper and sales, let's say it is 0.1. It means what? It means newspaper is not affecting the sales much. So what can be the prescription? The prescription can be like, as a business decision, you can, as a business person, you can decide to invest less on the newspaper because it is not affecting. Right. Using correlation, we can do it, or after building up the model, by analyzing the model performance, we can do it. Okay, a lot of ways are there to do the prescriptive analysis, right? That is just about suggestion of prescription. Okay. So we'll discuss that part also. Let's start with the predictive one. Okay. So for the predictive one, we need the understanding of what? We need the understanding of machine learning, right? So when I talk about machine learning, okay, why we use it? This is a very important component for AI. Okay, AI is something which is highly depend upon how machine get trained, right? How machine learn something, right? So here we use two important factor. One is called historical data. That means the event that already happened. Okay, what that already happened. That is important. Okay, plus algorithm. Some mathematical algorithm will use. That algorithm will try to understand the pattern within the historical data. Okay, that algorithm will try to do what? Will try to understand the pattern within the historical data, and then gives the predictive model, okay, to predict or forecast something for a data whose outcome is not known. Okay, to predict or forecast using a data whose outcome is not known. That is called predictive model, right? So this actually creates the definition of your machine learning, right? So if you will search for the machine learning definition, right, what you will get? You will get the similar kind of intelligence that enables computer system to learn and improve their performance from data. Okay, from data without explicit programming, right? That means without it's not like that you don't have to program. It's like, we don't have to do explicit. That means we don't need to tell the data, we don't need to tell the machine that how it should consider the data. Okay, machine will automatically identify the pattern, and based upon the pattern, existing pattern, it will try to make the prediction. So instead of being directly, okay, let me just copy this thing. Mhm. Okay, so it's a branch of that. Okay, instead of being directly told how to perform a task, okay, these systems are given a data and algorithm, as I told you, that allow them to learn the pattern and make the predictions or decision. All right, that is a simple definition of machine learning. Okay, like machine will try to learn, like as a human we are trying to learn, right? So now, when we are going for the machine learning, we need to know its types, right? What are the types of machine learning? So, types of machine learning. So, we have over here, first type is called supervised learning. Okay. Now, what is supervised learning? Under some supervision. Before we can understand supervised learning, we should know what is supervising something. Okay, what is supervising? It's like, suppose there is a project going on. So to work on a project, there used to be a team. Okay, like team member is there. Okay, so it's like there is someone who is called team lead. Okay, this team lead we can also call as a supervisor. Okay, there we have a different team member, or you can say the different executives. Team member 1, team member 2, team member 3. Okay, now this guy will give the instruction to their team members. Okay, these guys will get the instructions. Okay, instructions means what? Those instructions will work like a algorithm. Okay, now these guys will generate some output. Okay, now a supervisor will do what? Why this guy is called supervisor? This guy is called supervisor because this guy is already having the information about expected outcome. Okay, this guy actually know expected outcome, right? That's why it is called supervisor, isn't it? So when we get the output over here, whatever things they're creating, like website, they are working on a project, whatever, so that output will be compared with whom? The expected outcome. Okay, who will compare? Supervisor. And based upon the comparison, that supervisor can easily find out that what is expected and how much difference is there. How much difference is there between the outcome achieved, okay, or outcome generated. Okay, this is outcome generated. Okay, so how much difference do we have between the outcome generated and actual expected outcome? Okay, and based upon the difference, this guy will again give the new set of instruction. Okay, based on new set of instruction, again some output will come up. Okay, again this output will be compared with what? Expected outcome. Again based on the difference, again new set of instruction, right? So supervisor is doing what? Supervisor is guiding or supervising its team because this guy knows one of the important entity that is called expected outcome. Okay, if a supervisor don't know the expected outcome, okay, client had not, the client is like had not explained it properly or had not told it, okay, or had not given any expected outcome, then how supervisor will supervise? Not, a supervisor can't supervise, right? You know, supervisor can only supervise if the supervisor is having the expected outcome. Am I clear? Right? So same thing happened in supervised learning. Okay, for a supervised learning, what we required over here data, but that should be a labeled data. Okay, what? Labeled data. Now what is labeled data? Labeled data is like when we consider over here, let's say the sales value. Suppose I have to predict the sales value. So the problem statement given to us. Suppose someone had given this data to me, and after giving this data to me, asked, do one thing, build a predictive model that can predict sales. So I look at the data. Is there sales already existing here? Yes, sales is already existing. Right? That means it is a labeled data. Simple. Okay. So labeled data is what? That means whatever you have to predict, okay, whatever you have to forecast, that information is actually existing in the historical data shared with you. That is called what? Labeled data. All right. For example, let's say if you take any data from here, okay, okay, let's say this one. Just a minute. Okay, so let's check it out. So let's say we have this problem statement. The provided dataset appears to be related to diabetes and contains various biomedical measurement and patient. We have no, oh, what is this? No patient. Another identifier for the things for the patient. We have a gender, we have a age, urea level, okay, creatine level, HbA1c, cholesterol, HDL, LDL, VLDL, BMI, and then we have a class, right? So class is what? Non-diabetic, pre-diabetic, and diabetic, right? So when I read this thing, okay, this is a data description, and then this data has been, suppose this data has been given to build a model which can predict diabetic condition. So I look at the data. So in the data historically, do we have the target given that I want to predict? Yes. I want to build a model which can predict class, but in this is already there. Okay. So for a new event, when class is not known, for a new patient, class is not known, I need to predict class. But historically, it is already given. That means it is a labeled data. Data is already having the label. So this data can be used for what? Supervised learning. Clear? Let's say this one. The advertising data set captures the sales revenue. You have to build a model which can predict sales. So is it a labeled data? Yes. We have a labeled data. You can say over here that we have a features. Mhm. We have features given, and along with the features, labels are also given. That is called label data. All right, or you can say we have independent variables given. Independent variable.
Independent and variable X and Y.
Right.
X and Y.
Okay. Then we can use what? Supervised learning. Okay. So supervised learning requires a label data, right? Why it requires a label data? Because label data will work like a expected outcome for each sample. Okay. Here I told you expected outcome, right? So these label data in the process of learning, okay, in the process of learning, these label data will act as a expected outcome for each data sample that your algorithm will uh, try to achieve. Okay, like learning, when your algorithm will try to learn about a sample, it will try to do what? It will try to achieve the expected outcome. Okay, like suppose your algorithm picked the first data sample. After picking the first data sample, it will try to use some of the calculations so that the output can be n. If it is not n, it will again try to do calculate, make some changes, right? Same way, in this case, your algorithm, like in advertising data, your algorithm will try to use these informations and some calculations, some linear, non-linear calculations, so that the output can be this one, or output can be as close as possible to this one, and try to identify what makes the output closer to this one, which process, which coefficient, which kind of calculation, what are the calculations, what are the coefficient that make it possible, so that using these value I can come close to this one. And whatever the coefficient, or you can say the process, or whatever the calculations that it had used to come to this position can be used as a trained parameters. How it can be used as a trained parameters or learned parameters, which will be used later on making the predictions. That is called supervised learning. Am I clear? Any doubts in supervised learning? Anyone? Please tell me. All right. Now let's go ahead next, which is unsupervised. I hope this is clear. What is unsupervised? Unsupervised is a process in which we have a unlabeled data. That means the event is there, but what is the outcome of that event, that is not clear. Okay, like I have the information about the expense of a customer. Okay, expense of customer, right? I have information about income of a customer. Okay, I have information about age. I have information about the mode of payment, but I don't have information about like whether it is a potential or non-potential customer. Okay, these informations are given to me. Okay, there is no label present. Okay, label will be decided by whom? It will be decided by the problem statement. Okay, if the problem statement says over here, build a model to predict expense, build a model to predict expense, then it will become a labeled data because expense is already there. Okay, if problem statement says that build a model to predict expense, so it will become a labeled data. But if the model is saying that find high potential and low potential customers, okay, then this becomes unlabeled data because there is no label present over here stating it is a high potential or it is a low potential, right? So label, it is a labeled or not labeled, that totally depends upon like what is expected from you. All right, so it is unlabeled data, right? So what happened in unlabeled data? In unlabeled data, what will be the approach? The unlabeled data we will use to identify the pattern in the data and form different clusters or groups. Okay, like for example, I have a data like this, x2 and x1. Okay, like this. Okay, right, and there is no label existing over here, so I have to find out the pattern. So what I do, I'll just try to find out what are the informations which are having a similar behavior. Okay, like these are having a similar behavior, these are also having a similar behavior, and these are also having a similar behavior. All right, so we can form what? Clusters. Okay, and then we can recognize each clusters statistically. Like this is a cluster in which x1 is higher but x2 is lower. This is a cluster in which x1 is lower and x2 is also lower. This is a cluster in which x1 and x2 both are higher. I guess that's how we can recognize it statistically. Okay, let's take a data sample over here. See, first try to read the problem statement. To categorize the countries using socio-economic and health factors and determine the overall development of the country. So there is an NGO named Help International that is committed to fight poverty and providing people of backward countries with basic amenities and relief during the time of disasters and natural calamities. Okay, that is what Help do. Now let's say Help International have been able to raise $10 million. Now the CEO of the NGO needs to decide how to use this money strategically and efficiently. So CEO has to make the decision to choose a country that are in the driest sorry
The direct condition, very bad condition.
Right. So hence your job as a data scientist is to categorize the countries using some socio-economic and health factors, right? So we have information given like this, okay, in which it's like child mortality, exports, health, imports, income, inflation, life expectancy, total fertility, GDP. Now, it is not mentioned that this country actually needs help, this needs not help. So according to problem statement, label is not existing. So this is unlabeled data. So what we need to do? We need to perform over here unsupervised learning to find out different groups of countries, okay? And then out of different groups of countries, we will decide which one actually needs help and which one don't need help, right? So we can say over here in short that unsupervised learning is all about labeling the unlabeled data. Okay, it is what? Unsupervised learning, long story short, okay, is labeling unlabeled data. Am I clear? Okay, so how do we decide it's labeled or not labeled? It depends totally upon the problem statement, right? The third type of learning that we use over here, there is one more learning that is called semi-supervised. Okay, so semi-supervised is what? It's like, here we label them using unsupervised, and using that label we trigger the supervised learning. Okay, so semi-supervised actually exists somewhere between supervised and unsupervised. Okay, semi-supervised is a machine learning technique that utilizes both labeled and unlabeled data to train the model. It bridges the gap between supervised and unsupervised by leveraging the information from both type of data, particularly when labeled data is scarce or expensive to obtain. Okay, so how it actually works? It works like this. See, I have a labeled data. Okay, that labeled data, suppose I have 500 or 1000 samples of labeled data. Okay, and I have unlabeled data. Okay, suppose I have unlabeled data and this is let's say 5000 samples, right? So using this labeled data, we can build a model to predict, right? Using that model, we'll generate the label for these guys. Okay, and once we have a label for these guys, then we will use overall data to train a model, right? So that kind of process also we use. Okay, so semi-supervised, it's like suppose I have all the unlabeled data, then we just label them, then we can use it for supervising, right? So that's how we use it, but it is just a kind of a process which is you can say which is not a generic process, which is not a conventional process. It just kind of a this thing you can say it being generated according to requirement. Okay, it is supervised and unsupervised only is a generic process, but using supervised unsupervised, a new thing is being people had been created, like suppose someone get a data in which few of the sample was unlabeled, so few of the sample was labeled. So using the labeled, again using the labeled data, build a model, then label the unlabeled data, then use the whole data for the training. So people give it a name semi-supervised, right? Then we have a reinforcement learning. Reinforcement learning is something, as the name suggests, reinforce. Here the learning gets continuously reinforced with time. Okay, so how something get reinforced with time? Okay, how our learning happens? Our learning, one of the major role that plays that plays a very important role in our learning is reward and penalty. Okay, whenever we do a task, right, and if it is good, okay, somehow we get acknowledgement, right, or somehow we get appraisal, somehow we get people just appraised, acknowledged that yeah, this was a good thing. So that makes our brain learn that okay, this is what we used to do in our life. Okay, because we are getting acknowledged, right? Something we did and we get punished or suppose penalized. Suppose we are driving without wearing a seat belt, right? So we'll get penalized. So that also makes us learn that we should wear a seat belt. That is important. Okay. So our day-to-day learning is also based on what? This reward and punishment. Same reward and punishment system when we use to make a machine learn, or reward and penalty system to make a machine learn, that is called reinforcement learning. Okay, here we have 5 different entity. One is called agent. Agent is actually the machine. Then we have the environment. So by environment is something from where agent will capture the information. Okay, so agent environment. Then we have an action, and then this leads to 2 things, which is called reward and penalty. Okay, so it's like agent will do what? Will analyze the environment, and based upon the environment analysis, agent will take the action, and that action can go in either direction, can assign a reward to the agent or can assign a penalty to the agent. Understood? If it is rewarding, machine will be using the process again, will follow the same process again. But if it is penalty, machine will try to avoid that process or that particular activity. Okay, so reinforcement learning is guided by supervised learning. First, supervised learning happens. Okay, and once the supervised learning is done, thereafter we put the system into reinforcement learning. Okay, for example, we are creating a suppose self-driven car. Okay, so how self-driven car will be trained? It's a very time-taking training process, in which first it will be trained through a supervised process. Okay, there will be algorithm created which will be given a data, right? A data like different kinds of environment, like traffic signals. Okay, thereafter speed breakers, right? Thereafter lanes, right? Thereafter other cars, right? These kind of data will be given, right? And then it will be trained that when to drive. Like here it is brake. Okay, here is speed breaker is also it's like deaccelerate. Okay, lanes, it's like drive. Other cars, that means depend upon the other cars, like it is on the left or right kind of thing. So this will be supervised. Once supervised learning is done, we'll put it into the reinforcement. In that reinforcement, we will just allow the system to perform on its own, and there'll be monitoring system which will monitor its performance. Okay, like now it will be a monitor that will check that whether at the traffic signal it applied the brake or not. Okay, it didn't apply the brake, there that monitoring system will add a penalty to the agent. Okay, that is a negative reward point. Okay, it is like if it applied a brake and stopped at exact position or correct position, there will be a reward. So that reward and penalty, okay, will just go one, like in a repetitive manner. So that reward and penalty will end up making your machine trained. Okay, and that will reinforce the learning continuously. So continuously the performance and accuracy of the machine keep increasing, right? And at the end it will be a fully trained system, right? So this is what we'll go deeper into the upcoming session. We'll build up the model. We'll start with supervised. I will explain more into the supervised because supervised contain some more types. In the supervised we have regression, we have a classification, right? In unsupervised we have a clustering, we have
clustering hierarchy.
Yeah,
association.
Yeah, association rule is used for recommendation. Okay, so these things we'll deep dive and we'll try to implement it, and we'll see how can we build a model, how can we tune the model. So those,
and are we going to cover reinforcement learning as well as semi supervised learning?
See, semi-supervised learning, from the example I can take, it is semi-supervised is almost supervised only. Just a fancy name is given, kind of thing, but it is almost supervised.
One example of that.
Yeah, I'll take some example of that.
Labels, yeah, both the labels supervised. labeled and unlabeled, and then how we can do supervised learning,
Sure, sure.
and also reinforcement.
Reinforcement learning I think is not the part of this training, but just remind me once when I finish up the things like supervised, unsupervised, everything. Once I finished it, just remind me once. I will explain you, and I'll also take one of the case study for that, right?
Okay, please.
Okay, just remind me, right? Because I may forget because it is not in the DOC, so I may forget. So just remind me once that supervised.
But I am in the advanced one.
Yeah,
So maybe you will cover there the reinforcement learning also.
yeah, it's fine, it's fine. You can if it is over there, I'll definitely cover. But even if it
And
is not there, also suppose if it is not there, then also don't worry. Just remind me once. Okay, once I finish everything, I'll explain. Okay, there is not a big deal over there, right?
yeah, the one
They are
example of
not there, that doesn't matter.
reinforcement supervised,
Yeah.
so that one has that clarity also.
Right, definitely,
Reinforcement.
definitely. That's what I'm saying. Don't worry about it. Even if it is there, then obviously I'll tell you. But if it is not there, then also just remind me once. I'll tell you.
Okay, thank you so much.
Right, right. Okay, one more thing. I had uploaded one assignment also. The second assignment, had you tried? I guess you had not noticed also. Have you tried the assignment?
No, we
No?
will, not yet. I will try it.
Please, please, like whenever you have some spare time, okay,
Yes.
please do try, and so
And sir,
that once you finish this,
can you tell us
yeah,
how to navigate through the to this file, so that where to find the codes, where to find the assignment, where to find
it is getting updated in your classroom, right?
Okay.
Like this was the last session 7, right?
Okay.
The last, that means on Saturday, right? So this is a recording of that session, and when you click over here, right, you'll get to the data science 3 file. So data science 3 was done in the last session. So here the file, the code file, and here we have both the code file is there. Yeah.
3 means third class. 3 means third class.
Third class on data science, right?
Okay, that is how it is structured. Okay, fine.
Yeah, right.
And then what?
It is structured over here. You can structured over here. Like if you start from here, this is session 1. If you click, you will get all the files of session 1. Okay. Here it is session 2. Here it is session 2. The topic of session 2. All the files of session 2.
And also assignment in there.
Assignment, actually I have not. Where is assignment?
Assignment, I think, is in the questions and assignment section there.
Yeah, that is there, but assignment I had uploaded in this classroom or not, I'm checking it out.
For the first one you did.
So that's why I'm asking where to find all these things, so that we know.
Okay, here I have updated the assignment. On session 2, I have updated the assignment. Yes. On session 3, session 4. Session 4, and through session 4, here we started the numpy, session 5, and here session 6. Okay, so here I should update the assignment. Like I should attach it. I have not attached it. I'm sorry for that. Here is the assignment. I'll just take it from here, and I'll put it here. After session 6, assignment was there.
Okay,
so I'll just put it here. Okay, so here we have an assignment. So 2 assignments are there, one at session 2, other at session 6.
Okay.
Okay, so you can see over here, and whatever the topic covered, that is also mentioned. All right.
Yes.
And one more thing I'll attach over here, the data file that I'm using. Which data file I'm using?
The big data.
Right. Yeah, right. So BigMart, right? So I'll also attach the BigMart. This is
because here you're using Collab. I generally use Jupyter Notebook.
So if you open up the Collab file that is shared, automatically you'll get the data from there, right? Like for example, if you go here in data science 3, we have this file, right? So if you go here, that means if you just go to this thing, that is your classroom. Okay, if you go here, right, this is something attached, right? So if you go here, you will have the file like this. This is your file, the Python file, right? So when you open up this file, you'll get the data link over here.
Then you can go to the link and then
right. You can go to the link. Apart from that, I'll also attach BigMart sales figure Excel file we have, right? BigMart Excel file. Okay. CSV, BigMart sales figure. Oh, where is data file? I guess this is CSV file. This is not the file I'm using, right?
It's Bangalore.
It is the same file, but this is not the file I'm using. I'm using something different. Just a minute. BigMart.xlsx. Yeah, I'm using this one. Don't know where it is, but anyway. So if you go here, if you click on raw, it can be downloaded, or you can just click on raw. You can click on raw and you can click copy link. And this link you have to use in your code collab. Okay.
And on Jupyter Notebook.
Jupyter Notebook same. Like you in the Jupyter Notebook, I'll tell you. Just a minute, let me put it. When you open this link, for example, I added over here. Okay.
This is the Excel one.
So when you open this link, right? So you can download it from here. So once you downloaded it into your system, so it will be in your local system, and you can fetch it from your local system, right?
Okay.
Okay.
But it will be Excel format. So I have to
read Excel.
Yeah, so read Excel.
Yeah. Or you can right click here and copy this link. Raw, copy this link. And this link also you can use in read Excel.
Okay.
All right.